हाँ, जो पीछे बैठे लास्ट रो में।
Oh, lady, you must be 1920. It's 9:30 in the morning. Come and sit quickly. But please come and sit here.
बट ये सीट खाली लग रही है ना। ये वाला ये पूरा एंगल है ना, ये वाला हमको सीधा ही बैठते हैं आगे कुछ सही एंगल। सूर्य सूर्य ये वाले क्या
छोड़ रहे हैं बीच में दिखने नहीं रहा। कुछ लड़की मुझे बोला कि नहीं दिख रहा कैमरे में, मैंने यहाँ तो बोल आगे आ जाए इधर बोल दो आगे आने को। लड़की दिख रही है, देख लड़की दिख रही है रिपोर्ट में। इनको आगे कर दो फर्स्ट सीट पे।
People also sit as an audience, please. You all, जितने भी खड़े इधर, each
कोई से अंदर हो जा, दिख नहीं रही, नहीं दिख रही, बहुत कम दिख रही। अरे थोड़ा अंदर हो जाओ।
उधर पे ही कीजिए पहले, कैमरे पे वो खाली दिख रहा है, वो वाला एरिया, वो जस्ट नीचे कैमरे के नीचे। ये दिस सीट, ये देख रहे हैं ना, ये वाली सीट। ओ बेटा आयुष पीछे
तो नहीं दिख रहा।
दिखेगा दिखेगा, देखो अभी जाके बैठेगा ये दिस वन। इधर वाला एरिया पहले दिख गया। Today I will not give attendance even the first session. अगर कोई नहीं पहुंचता है यहाँ कि मैम हम लेट हो गए, ये हो गया वो हो गया।
बोलियो पीछे वालों को बोलो ना।
Okay, so I'm starting the meeting now. So I'm recording the video now. Okay? Everything better? Then start the meeting. Senior job उन job बेटा फिल दिस सीट फर्स्ट बार बार रिक्वेस्ट नहीं करेंगे प्लीज कम फर्स्ट हमें सेशन स्टार्ट करना है एंड फिल दिस फर्स्ट रो पहले ये वाला फिल कीजिए पहले कैमरे में सबसे पहले आता है अब थोड़ा फिल दिख रहा है फ्रंट वाला क्या फिल कीजिए इधर
इस मीटिंग में ज्वाइन
प्लीज कम हियर हाँ जी बैक वाली इधर आ जाइए
हाँ हाँ ठीक है ठीक है हम लोग देखो
श्रुति क्या नाम है आप हाँ बताइए this side. I think now he's
सर ये चल रहा है वैसे
हाँ ये चल रही है
पता नहीं क्यों
should I start? Hello, sir. Am I audible?
Yes, all good.
So sorry for the delay. We'll start the session now.
That's all right.
Good morning, everyone. It is a great pleasure to welcome you all to the session at Confluence 2026. Today, we have the honor of hosting a distinguished academic, industry expert, and thought leader whose work has significantly influenced the fields of information technology, software engineering, and agile practices. We are honored to introduce Dr. Bhuvan. Dr. Bhuvan is an accomplished IT professor of IT at the University of South Florida, Sarasota, Manatee. He is also founding consultant at Method Science and a co-founder and director at Platify. He has mastery in business analysis and requirements modeling, software engineering, big data strategies, agile process, mobile business, and green IT. His domain experience spans banking, financial services, insurance, government, and telecommunications. Bhuvan is a thought leader and author of strategies for agile business and the art of agile practice. His recent Qatar executive reports from Boston include topics such as psychology of agile, business transformation, collaborative business and enterprise agility, and agile practice, a composite approach. He is the recipient of several prestigious awards, including Computer Object 5, the Consensus IT Professional Award 2006, and the IT Writer Award 2010. He earned his doctorate in the area of object orientation from the University of Technology, Sydney in 1997. Dr. Unwekar is a fellow of the Australian Computer Society, an IEEE senior member, a professional Scrum Master, and a life member of Computer Society of India and the Baroda Management Association. He has also served in leadership and mentoring roles across professional and community organizations worldwide. We're truly honored to have him with us today. I now have the privilege of handing over the session to Professor Dr. Bhuvan Unwekar, who will share valuable insights on the role of schema flexible databases in enabling modern artificial intelligence and the integration of new SQL technologies with AI systems. So you can start your session.
Thank you. Namaste to all my friends. And good day to Keith, if Keith Sheringham is sitting in the audience, because I know I have sent him from Australia to go and enjoy my home country, India. Thank you for the introduction. Thank you, Garima ma'am, Juhi ma'am, everyone who has organized this event. And in the next roughly 20-25 minutes, I want to share something that I believe will be of value to both technical people and business people. So let me share my screen and then we move forward. let me know if you are able to see my presentation.
Yes, sir, it's visible.
Uh, okay, good. So, thank you once again. The topic is no SQL and artificial intelligence, how the two things are related. And it is a keynote. So I'm not going to dump too much of technology on you, but I do want people to get interested and to start seeing things in light of how the modern day data is sitting and how it relates to modern day artificial intelligence. So that's my plan. This is the agenda, which we will leave it as is. Where is my pointer? Okay. Um, I will talk a little bit about data types, but mainly I'm going to talk about what we call schema-less or schema-flexible databases. My love affair for MIT University goes 6 years back. In fact, goes more, but at least last 6 years I have presented at your university a few times in person, and so this is it for today. It started in person just when COVID was hitting, and I talked about deriving value from big data. Then I talked about environmental intelligence, which is still a very pet topic of mine. I have talked about AI and business optimization, on which my book on AI is. That's the key theme. I was there in Confluence 23, and then in 24 I did two activities. One was the faculty development program, and another was the keynote address. I have been researching in leadership, and I do think it is going to be a make or break thing. But what we are talking today is equally important, especially for leaders. And here is my honorary professor title, of which I'm very proud of. Thank you once again for the introductions. Couple of things I want to mention. First, of course, as the introduction, what is my pointer? As the introduction mentioned, I do a lot of writing, with the latest being psychology of agile, and agile is very important from not just project management but also in the AI field. I've got many students who I call scholars who are doing their postdoctoral work with me, and many of them have completed as well. Other than I'm from Vadodara, Gujarat, and I'm member of the Baroda Management Association as well. I do focus on agile. By the way, forgive me for the price tag, but I have shown this every time, and at the end of my presentation, one or two people from the audience get interested in my areas of work. So one is agility, another is modeling, which is where both SQL and NoSQL come into play, software engineering with unified modeling language. And then there are other books. Some couple of them I have written with my young friend Keith Sheringham, who is sitting out there, and those are the one that I just now showed. So the idea is to explore what all lies out there, how a student, a scholar, a faculty in a particular area of work suddenly can relate to other areas of work, including examples such as psychology of agile. And this is my core work in AI. And as you can see, it relates to business. And these are my areas of research. So again, anyone who is interested in any of these should reach out to me. I do a fair bit of work, not just books, but chapters and journal articles and so on. So that was my 4.5 minute of updating you all on how much I love and enjoy and celebrate MIT University. In fact, in my last visit, Dr. Garima took me to the Group Vice Chancellor Sir's office, and we spent a bit of time there too. In terms of what I am sharing with you today, it is really why business is interested in AI. Every time I talk to a business person, every time I talk to a leader, they say all the technologies are good, but they are of no value if they don't help us in making decisions. So data to decisions has always been there. Now we are talking also of going beyond, and I'm going to explain to you what I mean by going beyond. If we look at simply from data to decision, it is a evolving process that deals with people, process, technology, and money. And these four pillars, in my opinion, have played a very important role when any technology has been applied to business. So here is data, which is from observation, which is always in a mess. That is the definition of reality, business reality I'm talking. From there, we organize that data into information systems, we analyze it, we bring about collaborations, we provide services, technical services, and from there we generate insights and people make decisions. These are the business people, and the whole thing goes in an agile, iterative, incremental fashion. To do this, we need AI. AI is helping us improve our decisions in three different ways: improving the time taken to make decision, improving the accuracy, percentage wise, point wise of making a decision, and third, equally important, the number of points where decisions are made. This is still not modern day AI. So what is it that is happening? Well, we have always said, we as in the IT community, that data makes a business run smoother. Data is the oil, the new oil. Whosoever has data, bank, airline, insurance company, their business will run smoothly. But interestingly, people are now saying that data is also the soil, which means from data we can generate new things. And that is so true, because when we talk about any AI tool, it is really generative AI, creation of images, videos, stories, and even synthetic data. If we look at a basic neural network, artificial neural network, it's going to need a minimum of 1 million points, perhaps even more. Lots of iterations, epochs, so on. Sometimes we don't have the data, and Gen AI is actually helping create synthetic data. And therefore, my analogy of more soil than oil. These have been the paradigms, warehouses, lakes, and then we have started calling them lake houses, leading to various ML and BI applications. But what we are really moving into in today is a era, and this is actually a concocted name by me, but it may be around. It's a fabric. It is not located at one place, and it has a variety of structure, both of which are leading to my discussion why we need NoSQL as a storage mechanism rather than structured, because nothing is structured. For some young students who might be interested, I have listed all kind of learnings, all kind of AIs. You don't need to remember them. You just need to explore some of them and see how they are making a difference in the way business is run. For example, this is a big word. I have a few scholars who are working in this area, robotic process automation. It is picking up, mimicking bio patterns, the swarm patterns, particle swarm optimization, various patterns from nature, from bio, are inspiring process automation, supply chain management, fascinating areas. The question, of course, is rows and columns, however sophisticated they are, going to provide the the soil on which these kind of analytics exist? And in my opinion, no way. In fact, the whole of AI has progressed beyond imagination because we have the ability to store and now analyze data that does not fit in rows and columns. So what is the data? And this is a slightly older slide, and I have kept my figure numbers just to just to say that these are coming from some of my books. This one from my big data book. We have 5 V's for big data. High volume, and high volume is interesting. It cannot be said half a petabyte is high volume. It can be anything, but it is something that is difficult to analyze. It is streaming data. It is high velocity, and sensors are streaming in data even when humans are not generating it. Data is of different types: audio, video, graphics, sensors, text, of course, and mixed. And then the concern is how good is our data? We can easily have data that is running into half a petabyte, but may not be enough for us to even find a missing plane. I was talking about Malaysia Airlines that happened more than a decade ago, and in a age, in an era where our car can be easily found or cell phones can be found if they are lost, how come we humanity have lost a whole plane and not yet found it? And that is because of the quality of data, my presumption. And eventually business is interested in overall value that data is going to provide to them. And that leads us to this massive difference between the way we have seen data, text and numbers, versus the type of data that I have talked about. And even if we talk about text and numbers, if you see a email, um, um, a quality feedback to a airline, or just the login data, unstructured login data, you will find that it is like noodles rather than like biscuit. It's not organized. It is going all over and merging into each other. So that is why schema bound is not going to help us in our modern day quest for artificial intelligence, because AI systems require partial, not full observability, changes to features every second at times, and need continuous enrichment. I'm going to explain these two words in the next slide. But the idea is, if we have schema rigid data, our AI will break down. And therefore, we need storages for data that is not bound, not rigid by the schema. These are also concocted word, not by me, but I don't like these, but they are worth knowing because they are so popular that a structured data is going to sit in a SQL server. Oracle, of course, Oracle and SAP are going to now claim and are already claiming that they are NoSQL as well. But that data has atomicity, consistency, isolation of transactions, and permanence, durability. And we can simply reverse it to understand NoSQL databases at fundamental level. But someone has created basic availability, soft state, so not always consistent, and eventual consistency, which is coming from Hadoop and HDFC and MapReduce and the whole combination that Doug Cutting created. Thanks to him, we are in a state where data can be inconsistent and still providing tremendous value for our analytics, for our AI purpose. And therefore, we are really in. So these are some of the words that uh, students, especially who are technical, might be already experiencing, that whenever you are now writing an app, whenever you are now writing a solution, you are not really looking at the model view controller as a pattern, but rather multiple sources of parallelly stored databases and their analytics, which is data orchestration. So what did we do when we had SQL? So I have taken these screenshot from Access, which is Microsoft Access, and it has got a sample database, Northwind, which some of you might have tried. It is always rows and columns when it comes to customers and orders as two classic example. You will find that all of this is very rigidly defined. A customer ID, first name, last name, email, and phone. And it is also equally rigidly stored. So when it comes to storage, when we relate customers to say orders, we have to worry about primary key and primary key and foreign key. And those are the starting point for normalization in SQL databases. First, second, third goes up to fifth normal, and then we denormalize it for efficiency. This is how we used to use, well, this is a ER model, entity relationship model, but UML and class diagrams were doing the same thing. They were trying to help us model organizable data, structured data, in order to enable us to analyze it. But when it comes to creating or extracting features, when it comes to moving towards big data, towards AI, we have to take unstructured or semi-structured data and put it in a structured data before we can analyze it. And therefore, those who said no SQL, they actually meant no SQL, had to redefine what they meant and move towards not only SQL, because eventually unstructured and semi-structured data is put into some sort of structure for analysis. So that's another key thing that students and researchers would like to keep in mind. No SQL does not mean no schema at all. It is just that the schema is floating rather than put in concrete. And it is also coming into play during analysis rather than during storage. So if you look at, I'll show you a JSON example, and I'm sure students have written small basic JSON scripts in order to define data, in quotes, define in a not only structured query language format. So here is the example, and you will see that okay, this is a basic JSON. I am trying to define a product which has a price, which has some specifications, and so on. When it comes to specifications, it is a JSON within JSON, which I could not do when I showed you the customer and the orders records or tables, because now we have explicit field names which we can change, which can create chaos in NoSQL. The structure is self-describing. It is not rows and columns. So we should really call them blobs, binary large objects. They are not fixed by a relational schema. The fields can be nested, as I showed you just now, specs within product ID. And we can add new attributes. So if product ID P10234 has this structure, P10235 need not be following this structure. And that is the key to analyzing simply numbers and text in a semi or unstructured manner, like a financial report, like a newspaper report, like a cricket commentary, or like a customer feedback. All of these are unstructured slash semi structured. Here is a complete unstructured data, unanalyzable no matter what, and therefore has to be put in a format using JSON, using things like those tools. And here is a final comparison between SQL, well-structured, no SQL, just find based on order date, and order date need not be in the fourth column of orders table. I have to mention the three types of learning, but I'm aware of the time. I'll be speaking for another maybe 4 or 5 minutes and then conclude. But supervised is where we know the kind of data we are trying to analyze. So we are aware of the labels. In unsupervised, we are asking AI tools to provide us with themes, provide us with the labels. and then we decide how many Ks we want to provide depending on our experience. So experience is still there. And then when we are providing AI systems with feedback, and therefore they learn based on our feedback, is reinforcement learning. When I said soil, data is the soil, it can generate stories, it can generate images, it can generate videos. You must have heard last year, was it, or year before, but we had a major Hollywood artist strike because one artist, one recording, you can split it and store it in a unstructured NoSQL database, and you can create 10 different recordings out of it. This talk of mine you can record and you can feed a completely new topic to my slices, and it will speak as if I am speaking on a topic I don't even know about. Flowers and bees and and of course cricket. I do know a little bit about it. So generative output, hallucination control, prompt, and all these technical terms are telling us that now we are dealing with data that has not just been sourced from outside or through sensors, but is actually created by AI, which changes the dynamics. So we have unstructured and behavioral data, NoSQL data platform, feature extraction, retrieval, and generation, especially with LLMs like Google's. A couple of diagrams are not mine. I just want to acknowledge that the top row is talking about how data is stored and how, based on a query, LLM will answer by generating answers. Another technical diagram from this source, I liked it, so I kept it for someone who wants to do more research. Couple of words, technical words: behavioral data and alternative data. AI is going to learn not just from the data, but from data of the data, which is basically metadata. So things like click streams, for example, sensor trails, all these are metadata. And the NoSQL is going to learn. So that is your behavioral data. So see, in any of these types of data, you are not breaching the privacy of the client, and yet it is the client, it is the user who is providing this type of data. Similarly, in financial markets, when stocks are being analyzed, currency options are being analyzed, alternative data is coming into play. I will let you have a look at it if one or two of you are interested to see how alternative data, which is basically social media data about an organization, about a stock, about a currency that plays a role. And here, bitcoins and intersection between them and blockchains and analytics is also coming into play, playing a fairly major role. So really, we are saying that for AI, NoSQL is not just a store. NoSQL is more than a storage. It is a whole fundamental around how the new analytics are going, how the new analytics are growing. Couple of diagrams, as I said, are not mine, so I've kept them there for you to learn. But NoSQL will allow schemas to grow, will allow analytics to be reinforced, and will be always looking at behavioral data. And behavioral data and alternative data are the key to what we are trying to do in terms of analytics. Again, for those who are interested in technology, I have put the references there. My favorite, of course, is MongoDB, and I'm doing a fair bit of work. So if any students, especially final year students, want to do projects in MongoDB, I'll be quite interested in joining you guys. The last slide looks like noodles again, but this is about three and a half years worth of work called a big data framework for agile business, and it's looking quite messy and quite interesting. But there are these 5 modules in it, and then there are deliverables, and then there are the adoption process, strategy cube, big data manifesto, all the work I have done and published in my big data book. So the model underneath AI is the key, and that model is very fluid. Algorithms innovate fast, and architectures have to catch up with them. No SQL will allow intelligence to scale up and manage uncertainty. So the last two sentences are AI can compute, but is constrained by data architecture and design, and AI can generate depending on the context and availability of flexible data. So this is really a keynote, and these are the key points. Don't I don't think I have taught anything in this presentation. I have simply shared thoughts, ideas on how something like MongoDB. There are other. Cassandra is a columnar database. React is a key value database. Neo4j is a graphic database. Databases that help us relate in, Walmart use case of why beer and baby nappies should be stocked next to each other, and why milk should be right at the end of the store. This is all analytics, fascinating area. I have put some references here, including mine. The alternativedata.org will be of interest to you. And I have been speaking for 28 minutes and 52 seconds. So once again, I would like to thank everyone for the opportunity. I welcome you all to link in with me. My unhelker.com is dated, but that's my marketing. I was clean shaved when it was put together. And I'm going to now stop sharing and see if there is a quick question or two. I can see all of you now when I have stopped sharing. The classroom, the amphitheater is looking impressive. And if I'm not mistaken, is Keith sitting up in the first row somewhere? Anyway, over to you, Juhi ma'am and Garima ma'am and everyone. And if you have any questions, I can answer them. Thank you and namaste.
Thank you, Dr. Bhuvan Unkar, for such an insightful session. Your explanation of data architecture and its role in transforming data into meaningful decision, along with the perspective you shared on relational systems, SQL, and artificial intelligence was truly valuable. We sincerely appreciate your time and the knowledge you shared with us today. Before we conclude this session, I would now like to invite Professor Dr. Juhi Singh to kindly forward her gratitude to our esteemed speaker.
Hello, sir. I think Professor Keith wants to ask some questions from you first.
Sure.
Namaste, Kencho. G'day. How you going?
Very nice. Kemcho will not work in Delhi, but it will work with me. You're doing very well.
Thank you for your talk. One of the question is, one of the biggest challenges with AI is data. Its supply, continuity, access, permissions, and that sort of thing. Do you have anything to share with the room very quickly around that based upon all of your experiences?
Well, in terms of challenges, you have listed them, but what about quality? What about cybersecurity and so on? And I have been listening to some great AI speakers, way better than me, and they are telling me that the AI interface today is what DOS used to be 30 years, 40 years back, which tells me that the way we are even interacting with AI systems is very primitive compared to what is likely to happen. Even a three-dimensional presentation, unless it moves to holographic presentation, unless drones become a part of our regular life, delivering medications to accident victims or delivering pesticides in farms. Those are the areas where data is going to play a role, and that cannot be numbers and text. So to all the students in the class, in the audience, and the faculty, start thinking in terms of data that is not organized and is not rows and columns, and that's how we are going to move forward with these application of these technologies. I also just find it fascinating where we are going with ethics and law, because practically every thing that I said just now for last half an hour can be replicated by just feeding different text. Is that ethical? Are DAL-E and what is it, other video and photo generating tools of AI being used ethically? And Keith, you know that Australia has banned kids up to the age of 16 from accessing social media. Is that a real ban? What happens to kids in India who have access to it, whose cousins are in Australia? So, yeah, that's a long answer to a short question. What happens with data? A lot.
Much. Does anybody else want to ask a question before I throw it back to Matt? I can't be the only one with a question for Prof.
All right, sir. Thank you very much for this informative session. And I'm sure we have learned a lot from you. Your expertise in the subject was a true highlight. Thank you so much. I expect everyone to give him a huge round of well-deserved applause. Thank you. Good night.
Oh, thank you, thank you, thank you. All right. I'll I'll mute myself and see if I can listen to the next presentation. Is that okay? Okay. Bye everyone. Namaste and Keith, avjo.
अभी काम करो मैं खोलूँ मेल मेल होगा कल आएगा मेरे तरफ से ऑडियो है ना मैं अभी ना मैम जी मैम
Gaurav sir, am I audible?
Hello. Yes, ma'am. Yes.
Good morning, everyone. It is a pleasure to welcome you all to the session at Confluence. Today, we have the privilege of introducing a distinguished academic and researcher whose work has made a significant impact in the field of antennas, propagation, and next generation wireless technologies. We are honored to introduce Dr. Gaurav Varsani. Dr. Gaurav Varsani is an accomplished academic and researcher in antennas, propagation, and next generation wireless technologies. He has been consistently featured among the top 2% scientists in the world by Stanford University from 2021 to 2025 and has been listed among the top 200 reviewers of the IEEE Antennas and Propagation Society. He has published over 90 peer-reviewed journal papers and holds 16 granted patents. Dr. Varsani is the co-author of the book Dielectric Resonator Antenna for 5G Application, published by CRC Press, Taylor and Francis. He serves as associate editor of Wireless Personal Communications, Springer, and academic editor of the International Journal of Antennas and Propagation. He is also a guest editor for special issues on THZ, functional devices for 6GB systems. His excellence has been recognized with the KPR Legacy Award 2025 and the KPR Legacy and the KPR Rising Star Award 2025. We are truly honored to have you with us today. I now have the privilege of handing over the session to the Professor Dr. Gaurav Varsani, who will speak about next generation 6GB technologies and the role of artificial intelligence in microscale and advanced communication devices. Sir, you can start your session.
Yes. Am I audible, ma'am?
Yes, sir.
Yes. Okay. I think my introduction has been over. Okay. So I should present whatever my views. Let me share my work. Is my screen visible?
Yes, sir.
Okay. Yes. Thank you everyone for joining this session. I'm Dr. Gaurav Varshney, strictly working in the domain of electromagnetics. And here I had recently started working in this domain, how to use AI and related things and designing the different functional devices for 6G systems. So this is the topic, AI-driven approach to design the 6G functional devices. Let me tell you one thing, like what are the different devices like currently I'm working on. In my research group, I have around 20 PhD scholars and around 4 to 5 master's scholars and around 30 UG students who are working in this domain, and they are trying to develop some 6G systems and use case systems for 6G technology. And here the most basic thing that I can explain over here is on the name of 6G functional devices is absorber. So you can understand what is an absorber in very short view. Let me explain. So you know this curtain. This is about stealth technology. So what is absorber? You just try to understand this. This is curtain. And if you see the basic physics behind this curtain, like if you put some piece of cloth on your window or somewhere else on doors, then what happens? Electromagnetic signal comes and it interacts to this cloth, and then either it gets absorbed or reflected back. But inside the room, you get nothing. So transmission is approximately zero or with minimum capability, minimum intensity. Most of the power will be absorbed here. And the similar concept is being utilized in the case of solar cells that you can understand. There are thin films where sunlight is interacting incident on these thin films, and this complete sunlight is absorbed. And then you can convert by electrodes, you can convert this particular incident solar energy into the electrical energy. So this is the basic. In the similar way, we can perform in solar thermal absorbers. Just try to understand, if this curtain starts providing two functions. First function, we can put some electrodes on this curtain. We change the material which can store this incident electromagnetic wave in form of charge, and then it starts providing electrical energy. This is first function. In that case, this will be working as the solar cell. Second case is, if this incident energy is converted to heat, then what will happen in the cold places? Suppose there is some incident electromagnetic wave, then in that case, if this cloth or this material is able to convert that all the incident electromagnetic energy in form of heat, then this heat wave can be dissipated throughout the room, and we can develop some rooms which do not require, which can be a warmer without the requirement of external electricity or external power, you can understand. So in that way, there are two functions that you understand. First one is the solar cell, second one heat conversion and solar thermal storage. These two functions can be availed from this more advanced curtains that we are working on. We had recently designed, and we had patented this technology, and we are soon trying to deliver this to some certain industries too, and these will be available in the markets. Here we are strictly working on solar thermal storage of this energy. We collect solar energy and convert it into thermal. So in that case, in the cold places, in the cold times, in winters, we do not need blowers and other electric power, and we'll get the warmer rooms. In that case, so we can understand the basic mechanism and what is the use of AI in developing such kind of geometries or home appliances or the devices or the elements whichever are being utilized in multiple applications. So this is microscopic view of a cloth, you can understand, and here you can see this. Let me show you, like there is one box, we can remove this, add done it in that way. Okay, and in that case you can understand multiple unit cell. This one rectangular box is being called as the unit cell, and multiple unit cells are combined together to work as cloth, and this is thread, vertical threads, 3 vertical threads and certain 4 or multiple horizontal threads. These are making this rectangular kind of geometry, and this is being called as unit cell. It is having, in the language of electromagnetics, this is having particular dimensions, and this will provide us some resonance. Everyone studied physics in 12th standard, so this is that physics is we are utilizing in this rectangular unit cell will be providing resonance at certain frequency. At that frequency, we can design based on the dimension of this rectangular box or unit cell. And most probably this is micro scale or nanoscale dimensions, and this will be working in the optical frequency range from 250 nanometer to 750 nanometer, and that will be absorbing this visible spectrum. Okay, so this is what that we are talking about, this optical absorber. Curtain is an optical absorber. Okay, we can design absorbers for other frequencies, means we are having microwave frequency applications, stealth technologies for microwave applications, and recently we are moving towards the 6G technology, means terahertz frequency spectrum is dedicatedly working for the 6G systems. So which kind of absorbers we can design? This is a unit cell being formed by threads, and here in other frequencies, suppose this at the microwave frequency, we just want to design some absorber. So some basic unit cell structures are repetitively arranged in a periodic manner, like this unit cell of this cloth, you can understand. And then we can perform the action of absorption. So where this is required, you can understand this is the most prominent application where we can understand this uses of this absorbing structures, stealth technology. So this is fighter plane. Okay, and here what is the means action of fighter plane? Generally this is radar system. On the left side you can see. So what is the operation that you had studied in your 12th standard? Like radar system transmits some electromagnetic energy towards this fighter plane. Once this electromagnetic energy get interaction to this fighter plane, this reflects some electromagnetic signal. After interaction of this wave to this fighter plane, this electromagnetic signal is reflected back. This is known as echo signal, and these echo signals are being received by this radar system. In the first step, this is transmitting signal. In second step, this is receiving signals. Okay, so once this is completely received this signal, this has completely received this signal coming from this after interaction of this, means from this target or fighter plane. We can, based on this Doppler effect, we can calculate the velocity, speed of this target fighter plane, whether this is and direction of movement, whether this is moving towards a radar system or moving away from the radar system. So this is one thing. Based on this Doppler effect, we can work. So what is the main problem? Main problem, suppose this is our fighter plane and we do not want it to disclose it to other countries with whom we are fighting right now. Okay, so in that case, in the stealth technology, we do never want that our foe who is having deployed radar system can identify whether our fighter plane is coming or anything else. So in that case, can we do one thing, like we can design such kind of observers and we can paste it at the top surface of this fighter plane. So once we will be pasting these absorbers at the top surface of this fighter plane, then the problem, this is the main problem, reflected signal. This signal will not be reflected back, and all the signal will be absorbed at the surface of this fighter plane and then dissipated in form of multiple, most probably in form of heat or in other ways in environment. Okay. So in that case, once this reflected signal is mitigated, this radar will not be able to identify whether a fighter plane is moving towards this radar system or not. And we'll hit the target, we will come back. So this is stealth technology. So this is the most prominent and highly technical use of this absorbing structures. Since starting from this curtain, we had come towards this development of this stealth technology. Another component for 6G systems that we are going to design is an antenna. Okay, like you can understand, whatever is the transmission of the signal means happening just because of one element. This is being called as an antenna, and here this signal is being received at the radar system. This action is still being performed by antenna. So antenna is another very key element which is behind the development of wireless systems. So this kind of antenna, every antenna is having different geometry. Like you can see, this is having half cylindrical, half split cylindrical structures. This is having some half hexagon and rectangular composite structures. So in that case, here we are having two antennas, and if we need the different characteristics, like this is the radiated beam of antenna, radiated power of antenna, you can see here over here. So this envelope of radiated power being represented by multiple colors. Red color shows the maximum intensity of the radiations, and other green color and other color shows the minimum intensity of the radiations. So here in the center, you can say one antenna is placed. This based on this geometry, which geometry is means based on this geometry, which geometry we are utilizing, we have designed, we can attain the different radiation envelope in free space. So which this is manual efforts right now. This is a manual effort how to means the person dealing with core electromagnetics, they can understand the boundary conditions where we have to put this metallic boundary, where we have to use this dielectric boundary, where we can and how we can utilize the different geometries, which kind of geometry will be providing which kind of radian sphere or radiation fields, and this response, which kind of geometry will be providing this response. This is totally based on manual efforts right now. And you can see this is like a skill of a person dealing with the electromagnetics. How much that person is skillful, that will be defined, that will be defining which kind of characteristics we are obtaining from the antennas. Okay, so in that case, can we do one thing? Right now, we are working to make this design fluent, and we just want to keep it free from manual efforts. We are utilizing what we are doing. We are utilizing some initial structures, initial guess, initial dimensions of this antenna, or any geometry or absorber that we had utilized over here, initial dimensions, initial values of the dimensions. We are collecting the data, utilizing some relevant softwares. And once we had collected the data, then we can design that, we can develop some machine learning or AI based approach that can provide us the exact design on which means this antenna will be resonating. Like currently this is working at 2.83 gigahertz, 4.85 gigahertz. So at this at particular frequency, this and we can design an antenna without any manual efforts. We can decide the geometry, we can decide the boundary conditions, we can decide such radiation field, which this envelope of this radiated field, and this envelope of this frequency response, it's a resonance frequency based on this AI. Okay, so this is the current trends in electromagnetics which is going on. We are trying to incorporate artificial intelligence in designing the multiple components of electromagnetics that can serve our nation or our technology throughout the globe. So this is a task for you guys. You are the computer science students, most probably. Can you develop algorithm or some specific approach which can help us for making some geometries of observers, antennas, modulators, filters, and many more components you are having right now. Okay, so and why this is required? This is one more thing, like dimensions of these components. At 6G technology, you can see this at the 6G technology specifically, you can see the frequency ranges around 114 gigahertz, which is sub 1 gigahertz, and beyond that up to 300 gigahertz, and beyond that up to 3 terahertz we can go for 6G systems that we are seeking. In fact, beyond that up to 10 terahertz, we are trying to develop some systems which can work for, which can enable us to be working with these 6G systems. And the basic requirement is like you can understand what is the requirement of 6G. Like whenever we were utilizing 3G, 2G or 1G, we were not be able to transmit the video call. Right now, on using 4G and 5G, we are able to talk to our relatives with some on video calls in 6G. So this is happening. This is possible just because of we are enabling the higher data transfer rate. Okay, so using 6G technology, we'll be having the wider bandwidth, channel bandwidth, and in that case, we will be able to transmit data in high speed, further higher speed. And in that case, this multiple applications will be fluently working for our future communication systems. And since these systems are working at the terahertz frequency range, in that case, this dimension of this all the components remains in micrometer and nanometer. So you can understand if dimension is in micrometer or nanometer, like this is right now, this is very difficult to design systems, it's difficult to fabricate the systems continuously because this fabrication requires a cumbersome mechanism and machinery and multiple things you can understand, like nanoscale chip. This designing of nano chip is very difficult. So in that case, AI will be helping us. We can design, we can define the dimensions exactly, we can define the characteristics exactly, and then we can mitigate the continuous lethargic process. We can find out the direct solutions. And also we can reduce the manual effort. So this is a task for you guys to develop such kind of mechanism. Our nation is working means striving hard to develop such algorithm, and we are a part of that right now in my research. Thank you very much. Thanks for joining this. This is my website through which you can connect to us, www.gauravvaishnaw.com. You can join us for multiple, research programs. You can collaborate with us. You can send your students for internships. We are having few paid internships as well. You can apply through email or website. You can collect forms, and we can provide you some paid internships as well. We are highly working for these 6G systems. Thank you. Thanks very much.
यहाँ पे screenshot.
If there is any query, please let me know, and or you can connect to me through website or via email. You can drop your queries to me. Thank you.
Thank you, sir. As we conclude this enlightening session, the session provided a clear and insightful understanding of observers by explaining the microscopic behavior of materials, the challenges of wave interaction between fighter aircraft, and the importance of target velocity measurement. We extend our senior gratitude to Dr. Gaurav Barsine for sharing his knowledge and experience and vision. His words have not only enriched our understanding but also inspired us to think beyond conventional boundaries. To mark our respect and appreciation, we will now follow a tradition and rooted in sustainability and gratitude. I kindly invite Professor Juhi Ma'am to facilitate our esteemed speaker by presenting a Tulsi sapling, symbolizing knowledge, growth, and a greener future. Ma'am, may I? Hello, sir. Thank you so much for your session. That was a very informative one. However, this conference was in online mode, so we are unable to present you this sapling, this token of gratitude to you physically. We would like to extend it, we would like to offer it virtually to you. Kindly accept our token of gratitude and appreciation. Thank you very much. Thank you very much for joining us.
Yeah, thank you, ma'am. Thank you.
Good morning, Saurabh sir. Am I audible?
Yes, hi ma'am. Yes, you're audible.
Good morning, sir. We'll start the session now. Good morning, everyone. It is a great pleasure to welcome you all to the session at Confluence 2026. Today, we have the privilege of introducing a distinguished applied scientist and researcher whose work bridges advanced artificial intelligence research with real-world impact across multiple domains. We are honored to introduce Dr. Saurabh Yadav. Dr. Saurabh Yadav is an applied scientist too at Amazon with a PhD in computer science and engineering and over 5 years of experience in applying research and industrial AI. His expertise spans machine learning, generative AI, and large language models, including RAG systems and transformer fine-tuning. He has made significant contributions to data privacy and security through privacy-preserving AI and location and text or fiction techniques. Dr. Yadav has deployed scalable AI solutions using cloud platforms and MLOP's best practices. He has authored over 20 research publications in top-tier conferences across areas such as spatial privacy, blockchain, bioinformatics, and his work is research and institutions in healthcare, finance, and bioinformatics. We're truly honored to have you with us today. And I have the privilege of session to Dr. Saurabh Yadav, who will discuss how large language models are fine-tuned alignment techniques and preference-based learning. So you can start your session.
Okay. Thank you so much for this warm introduction. Let me just share my slides. Yes. Jane, ma'am, can you please confirm my screen is visible, right?
Yes, sir, it is. It is.
Okay. Thank you so much. Okay. Hi, everyone. Good morning to everyone. Thanks for being here, first of all. It's my privilege to be here, invited as a lecturer over here to just deliver some of my viewpoints on LLMs and how to, fine tune, take the feedback, align towards the preferred replies you want to have. My name is Dr. Saurabh. I am currently working as applied scientist at Amazon, where basically I focus on machine learning systems used in large scale and real world applications. Today, I want to talk about something that sits at the intersection of machine learning, human judgment, and responsible AI. How we teach large language model not just to generate text, but to behave in a way that human actually prefers. Over the last few years, large language models has become incredibly powerful. They can write, they can explain, they can reason, and even they can hold the conversations as well. But power alone is not enough, right? So the central question I want to explore today, even when a model gives a correct answer, how do we know it is helpful, safe, or you can say like appropriate from the human point of view? This is where the idea of preference alignment comes in, and that will be the focus of this talk today. So let me just quickly go through the what we are going to cover in this presentation. I'll start with the basic and gradually build towards the preference alignment work in the model language models. I'll start with explaining what are LLMs, what are large language model actually, and how these models are generating the text. Then I'll talk about how LLMs are trained during pre-training. From there, I'll introduce the fine-tuning part of it. This will basically lead us to problem of misalignment. And once we understand that problem, I'll show how the human preferences can be used to learn signal and how like the feedback mechanism allows us to align the model behavior with what human actually wants. Towards the end, I'll briefly touch why preference alignment matters in real world applications and deployments and highlight some open challenges that are still active in the research areas. The goal is not to go deep in the mathematics because it is a very vast topic, but to build a clear mental model, how alignment works and why it matters. So let me start with the very basic question, what is large language model? A short form towards LLMs. Okay, so at its core, it is a machine learning model that predicts the next piece of text based on what it has seen so far. So that's it. That's the entire definition. There is no built-in understanding of meanings, intentions, or correctness. The model simply learns patterns in the languages and uses those patterns to predict what comes next. For example, if I give you the sentence like sun rises in the dash dash dash, so most of you would naturally complete it with east, right? So LLM does the same thing in a very similar format, except instead of intuitions, it relies on the probabilistic models, on the probabilities learned from massive amount of ticks. To do this, the model first breaks into text into the smaller units, which are called tokens. And tokens are always not full words. You cannot you can think of them as a part of words, symbols, punctuation, or a complete word as well. Once the text is converted into tokens, model processes them and produces the probability distributions over the over all the vocabulary or the possible next tokens. The token with the highest probability is selected, added to the input, and the process repeats itself, and one token at a time. So this is the entire process, how the things goes into the process and how the things actually work for training up the LLMs and training up of any neural network model where the text things are associated. And this is how the long paragraphs, explanations, and conversations are actually generated. If we talk about how the LLMs are pre-trained, so let me just understand. Let's try to understand how LLMs generate text. How does it learns the pattern in the first place? So what happens is the initial training phase for any LLM is called pre-training. During pre-training, the model is exposed to the massive amount of text, things like books, articles, websites, or maybe like the code, Wikipedia, anything. Okay, those are which are the things which are, or maybe you can say the literature which is collected from any of the internet scale or any from all offline source. Those are something which acts as a data for any model for pre-training part. So what happens is, as I said earlier in the last slide, the text is first cleaned, broken into tokens, which are then converted into numerical embeddings. So these embeddings are passed through multiple transformer layers that basically uses self-attentions to learn the relationship between the words across the long context. The training object is very simple. Predict the next token given the previous token. And if we talk about the process of the transformer, as I have used the word self-attention, let me just give you the quick definition of that thing in the previous slide. I missed that part. So self-attention is something which is a part of transformer architectures. It is very much similar to the neural network architecture. And self-attention is something which allows the model to look at all the previous token at the same time and decide which one are the most important for predicting the next token. For example, in a long sentences, the meaning of a word often depends upon something which appeared much earlier in the self-attention, much earlier in the context or in the sentence, right? So self-attention helps the model to capture those long-range dependencies. And because of this attention mechanisms, transformers can handle the long context, maintain coherence, and also generate the fluent text over the, you can say, over many sentences. It is important to understand transformer itself. It's just a mechanism. It is the engine that processes the information. What actually defines LLM is the objective it is to train on, okay, which is basically to predict the next token. Let me jump back to the next slide. So the learning process here is self-supervised, as I was telling earlier. So this means there is no human explicitly labeling the data or judging the outputs. Instead, the model learns by repeatedly trying to predict the next tokens in the sequence and adjusting its parameter when it gets the predicting when the prediction is going wrong. The only objective the model is optimizing during the pre-training is next token likelihood. In other words, the model is rewarded for producing the text that is statistically likely given what it has seen in the data. If a particular pattern appears frequently in the training data, the model will learn it at its will. And if pattern appears rarely, the model may learn in poorly or maybe any wrong format, regardless of whether that pattern is correct, helpful, or safe. So what's important here to notice is it is completely missing from there is no notion of human preference, you can say. No one is telling the model which answer is better than others. No one is judging whether the response is harmful, safe, or you can say appropriate as well. So, pre-training teaches the model how the language works. It does not teach how they should behave when interacting with the humans. So, after pre-training, we end up with a model that is fluent enough, which is knowledgeable as well, but still it is not aligned with the human expectations. Um, so what we do is, so after pre-training, we have, as I said, we have the fluent model, knowledgeable and everything. But when we start using these model in a real human-centric, human-facing settings, we quickly notice some serious problem, which are mostly like, it might sound it can produce answers which are very confident, but actually incorrect or incomplete a lot of time. I'm pretty sure everyone in this hall and in this meeting might have used ChatGPT or any of the generative models, and they might have generated some of the garbage or some not useful information, or maybe sometime it might have generated over of the information, like, which is not even required. So what we call this phenomena is generally referred as hallucinations. So the reason this happen is not model is trying to mislead us. It is simply doing what it is trained to do, producing text that looks statistically likely towards the response or towards the query which we have asked for. From the model's point of view, a confident sounding incorrect answer and genuine correct answer are just two different sequence of tokens, nothing else. So another important issue is that, like, the pre-trained model has no built-in notion of helpfulness or safety. They don't know when, like, answer needs additional context, cautions, or disclaimers. So they also don't know, like, when it would be better to say I don't know instead of generating the response. Generally, you might see in whenever we have any query in ChatGPT, we put it in ChatGPT. Whatever we say, like, for example, we said, like, okay, we want to go with approach A. It will respond with, like, yes, it is a great approach. You can follow up with this approach and blah blah blah. And second, at the very next moment, if you say, okay, I don't feel approach A is right, approach B will be the more helpful solution, then in that case, it will respond with, yes, you are exactly right. Approach B will be better than that. I think everyone might have experienced that part, right? So what happens is, like, it is not, generating the response which is centric towards your things, or maybe not giving the right appropriate feedback or anything regarding to that correctness point of view and helpfulness point of view. So, the natural response to this problem is, like, to try to fix it by fine-tuning models. I'll explain, like, what is fine-tuning, but, like, let's try to have some kind of example. So this slide basically captures like the core problem we have been building towards, the problem of misalignment. On the left side, you can see like this particular area. We have how typically pre-trained model behaves. It aligns with the likelihood, meaning it generates the responses that are statistically plausible given the training data. I like see through the left side of the visual, if you can see, how can I? Is it safe to? The model often responds confidently. The response may even sound fluent as well, logical, and even correct as well. But it is optimized for plausibility, not intent. Okay. The model does not actually understand what user is trying to achieve or what consequences will be like through its response. So it does not reason about safety, responsibility, or human values. It simply produces like the completion that looks likely based on the patterns it has seen during the training. And this is why the correct answer can still be misleading or even harmful as well. And also on the right side, you can see, to just have the clarity about that, we see what alignment with the human intent looks like. So here's a response shaped not just with what is statistically likely, but what human would actually prefer. Model pauses, adds caution, asks clarifying questions, or reframes the response in a safer and more helpful way. So the key difference here is not intelligence. It is basically the alignment which I'm just trying to focus on. So our system produces plausible completions. Then the other produces the human preferred responses. So the problem of misalignment arises because LLMs are trained to optimize likelihood, not intent, not safety, not human judgments. And as a result, even highly capable model can behave in a way that conflicts with the what actually human is expecting out of it. Here is very simple example. You can see this medication will blah blah blah. It's highly effective, right? It is very much confident, but it is not giving any form of disclaimer. And on the other side, you can see there is a overconfident explanation about things. So the system outage is due to server failure. It is it could be certainly a DOS attack. It could be 100% secure. So there is a missing context out of it, right? So this is the classic example, and you can say it is potentially harmful and misleading as well for the people who are using these LLM or like the large language model kind of structures. So far, what we have seen, LLMs can produce answers that are fluent and even correct as well, but still they misalign with what human expects, right? So this naturally raises the important question, which we want to actually address, which is, if correctness is not enough, what should these models actually learn from them? Like, as everyone you might know, in neural network, what we have, we can give the data to the model, we can create new architectures towards that, so that like the training curves and loss curves, all these optimizations can happen. But to deal with this kind of approach or this kind of problem, like human based alignment and all of those things, what could be the simple thing? The key idea behind preference alignment is very simple. Instead of telling the model what correct answer is, we tell like what kind of answer we want to prefer actually while the training process goes on. So humans are very good at making relative judgment. We all know that, right? We all face those things in general life. Why not use that capability of humans and just put that thing into the data and ask the model to train upon that, right? So if I show like two responses to the same question, you may find like it is difficult to label one as an absolute correct or incorrect, but you can like almost instantly say like which one is clearer, safer, or you can say like which is more helpful in that way. So these kinds of comparison captures much richer information than traditional labels. Preferences naturally encodes things like tone, caution, clarity, and appropriateness. This is like psychologically, human psychology actually works in that way. A lot of psychological researchers have also proven this thing, that whenever we have like preferences, we generally tend to give them in a more clarity, in more appropriateness, in really great tonality and everything. So this reflects how a human actually evaluate answer as well in the real world situation. And they just don't think of whether the answer is technically correct or not. They just give their preferences, right? So from alignment perspective, preference answer a different question. It doesn't answer like, is this answer correct? But it answers like what human would want. So traditionally, you can say like the traditional supervised learning assumes there is a single correct answer, but in many real world interactions, especially open-ended ones, um, there are multiple acceptable responses. Some are like simply better than others. So that's it. That's the core base of the kind of data, right? So once we start thinking in terms of preferences rather than label, the next challenge becomes very much clear. How do we actually use human preferences to change the behavior of LLMs, right? So um, now that like we have understood the human preferences, how do we actually use them to train the model, right? So this is where like human feedback loop comes into the picture. The process starts by asking the language model to generate the multiple responses from the same prompt. By prompt, when I say like that is a kind of query which put forward in any of the LLM model. So instead of producing just one answer, model produces several possible answers. Okay, and these responses like are then shown to the humans. They can be annotators, experts, reviewers, like who you can ask to compare them, right? Generally, in large industries, we literally, focus on annotators to annotate the response from the LLM. Even in my organization, we have a big team for annotators who annotates this kind of data. So they don't need to write the perfect answer. They simply indicate like which response they prefer. Or maybe you can say the rank the responses from best to worst. Okay, so this human comparison are then used to train the separate model, often called as what we call as reward model. You can see in that pipeline as well. We generate the responses, rank or compare, we train the reward model. So finally, what happens is the job of the reward model is to predict which response of the human would prefer, basically. And finally, the original language model is optimized to produce the responses that scores higher according to the reward model. Over the time, this pushes the model to behave that like aligns it pushes the model towards like behavior that aligns better with the human expectations. So what's important here is that we are not hard coding the rules. We are not explicitly telling the model that what is right or what is wrong. We are letting it behave from human judgment, or maybe letting it learn the behavior from the human judgment. So what happens is like preference alignment is not about making the model more knowledgeable. It is about like shaping how that knowledge is, expressed. So there are different ways to implement this idea in practice, depending upon like what kind of trade-offs we have, what actually we want to make out of it, and all of those kind of things. So um, once we have like human preferences and a feedback signal, the next question is how actually we can use those signals to update the model. This isn't a single way to do this, and there are like lot of different techniques in the market which can be explored to do this kind of preference alignment. So in practice, alignment can be implemented with like different optimization strategies. What all these approaches have in common is pushing the model towards the responses that human prefers. And I'm stressing like a lot of time in human preference because that's the core aim for like the preference alignment. It can be any form of preference. I'm taking it as a human preference, but it can be any. So a lot of papers, lot of active research has been done where the adversarial learning is also taking into place. So LLM is treated as a judge for a particular response for any other LLM. So that's the kind of structure is also going on. So this was like one small example, like how the things are actually happening in the industry. So one class of approach basically uses the reinforcement learning. Here, reward model assigns the score to different responses. The language model is optimized to maximize that particular reward. So this approach is basically very much flexible and powerful and most actively being used technique, but it is like somewhere expensive and complex to scale as well. Another class of approach skips the reinforcement learning altogether. Instead, model is trained directly on a pair of preferred and non-preferred responses. We generally call it as DPO approach, which is direct preference optimization. So this makes training simpler and more stable. So what we take is simply we just take one right and one wrong pair of answers and says like, okay, this is the right answer and this is the wrong answer to the model, and we just update the reward model on the basis of that. And the third approach, as we all know, it's like the fixed data set of human feedback. As I mentioned, like human annotators we have in picture, we just get the data annotated from the humans and pass that data saying that, okay, this answer is more preferred and this is, um, can be used as in a different form. And generally, as far as today's industry is concerned, like lot of industrial people, either Amazon, either Microsoft, Nvidia, any of the big folks you can think of, Meta, they are using this method because like it from the cost point of view, it makes them like the process entirely cheaper and easier to reproduce, but they cannot adapt the changing preferences over the time. This is the limitation of this part as well. So the important takeaway is that like the alignment is driven by the preference signal, not by the single algorithm. Optimization methods is something which is the engineering choices. Now, because of these approaches, and because these approaches comes with a trade-off, researchers and practitioners are like continuing to explore new and new techniques for the preference alignments. I'll just show some of the preference alignment technique actively being used in the market again. We can just like you can just see there are like five. I think five I have mentioned, and there are a lot more as well. And there are a lot of ensemble modeling also going on in these techniques so that the more scalable solution can be built. So, and it is very basic and core approaches. For example, SFT. At the simplest level, SFT is something which is used by every other industrialist, or maybe, whenever we have any form of preference alignment task, we simply have the experiment upon SFT because, it is the simplest form of fine tuning or simplest form of, preference alignment thing for the model. This basically like improves instruction following and usability. But what happens is it does not capture the relative human preferences, right? And the model learns from individual responses, not from the comparisons. So, like basically in the SFT, what we pass is just the right answer, not like what is right and what is wrong. Okay. Then second comes this RLHF, which is reinforcement learning from human feedback. It explicitly optimizes the model using the learned reward models. This allows like for more stronger alignment with human judgment, but also it introduces like the additional complexity, which is like the cost, which I said earlier. Training can be unstable also, and skilling requires like very careful engineering in this particular kind of approach. But again, this is also another active form of approach being used. Now, I would like to mention very recent and most modern variant of preference alignment, which is GRPO and DPO. Most recent approach that aims to specify this process. Again, as I mentioned in PPO and like the DPO approach, which I mentioned earlier, we give the pair of responses, right? In GRPO, what we do is like we just group the responses. Okay, and what we do is like we have similar form of like 5 to 7 responses, and then we just rate each of the responses, like which is more preferable, which is not. Rather than having just binary right and wrong, we have the preference things. So that this is also one of the most widely used technique, and it improves the stability and efficiencies of like policy optimization while using the what you can say like the reward functions again. Then last, as I mentioned, offline preference learning. Preference learning uses the fixed data set of human feedback. This makes like experiment easier to reproduce and cheaper to run, but it limits the adaptability when preference changes. So that's the trade-off between that technology. So the key takeaway from this entire table is like there are like a lot of other approaches as well, but like we can just have like key takeaway that preference alignment is like something which designs a space, not a single algorithm. Different approaches required like different alignment strategies. What matters most is choosing the right approach for the problem you're trying to solve, or maybe you are having into the consideration right now. Okay, so far like we have talked about preference alignment as a technical idea. Now I would like to briefly explain like why it actually matters in the real world. In practice, large language models are deployed in settings where humans rely on their outputs: customer supports, education, healthcare, enterprise systems, or any other form of like decision support tools, right? So in these settings, correctness alone is not enough, right? User care about whether the response is helpful, safe, and appropriate. Say, for example, healthcare, right? If you take any suggestion from ChatGPT, you would expect that it should not be having any side effect. Whatever the treatment it is suggesting you, it should be safe to use. In education, whatever you're learning, right, you need to have the right learning curve towards that. It should not be vague enough, or it should not be what you can say like multi meaning thing, multi modality things, and all of those things. You want very specific answer towards what the specific question you need, right? So preference alignment basically helps to reduce undesirable behavior, such as like hallucination, overconfidence, unsafe, and all of those things. By learning from human feedback, model becomes like better at expressing uncertainty. Also adds like more context towards whatever the query you want, corresponding to whatever the query you want an answer for, and choosing like the safer defaults, like what we call it as a default, right? So this is what allows the language model to move from impressive demos to system that actually um, that can be deployed and scaled in the real time. Without without models, without alignment, models are very much powerful, but it is generally risky to use. At this point, it is important to be clear about one thing, that preference alignment has made significant progress, but it is far from solved problem. It is like actively researched area of space. In fact, many of the hardest challenge in alignment are still open research questions. One of the major challenge in like the human preference themselves are non-uniform. They vary across individual cultures, context, different languages, different everything. So like what one group find helpful or appropriate, other group may not like it, right? So we need to have very much a good amount of dynamic nature from each and every model, and from like zone A to zone B, if we are moving, the answer should also propagate in that fashion itself. Another challenge is scalability. As I just mentioned, like we want to move from zone A to zone B. So high quality human feedback is, expensive and time consuming to collect. As a model grow larger and are deployed in more settings, relying purely on human annotation becomes increasingly difficult. Because, for example, if someone sitting in US aligns the data for the US marketplaces, and the Indian marketplaces are totally different than the US. European markets are totally different than US. So data annotated over there in US, cannot be much of a use in Indian market, much of a use, not in like not of a much use in Australian market as well. So we need to have like proper structure to follow to solve these things. So it is another form of highly actively researched area. And also like as I mentioned, alignment also involves like balancing multiple sometimes conflicting objectives as well, right? So for example, a response that is very helpful may always not be safest as well. So a response that avoids the risk might be, less informative as well. So there is a risk of over optimizing for a specific reward and preference signal. So model may learn to exploit weaknesses, or maybe weaknesses in the feedback process rather than genuinely aligning the human intent, and preferences learned in one domain may not generalize well to others as well. With this perspective, let me just summarize and the key takeaway from today's talk. LLM, as I mentioned, learns language extremely well during the pre-training, but they do not align with the human values and the preferences. Fine-tuning is one of the approach which improves the instructions following, but it still does not guarantee that like model behavior aligns with what human actually wants. Human preferences provides a richer learning, or we can say richer learning signals actually, than like the correctness alone. They allow us to capture quality like helpfulness, safety, tone, and appropriateness. Um, so answer to all things are preference alignment for the any of the form of model, which allows us to shape not just what model knows, but also how they express that knowledge. At the same time, alignment is not like one-time solution again. It is ongoing research and engineering challenges are actually being, working actively to evolve this kind of structure so that more, user-centric LLMs can be generated and user-centric response from LLM can be generated. Thank you so much. This ends my talk for now. I'm open to have questions, and yes, anyone who's having some questions or some doubts to get an answer for.
Ask. I don't have. Then what will you ask me?
Anyone? No?
Sir,
Hello, sir. Are we audible to you?
Yes. Now I think your voice was speaking earlier, but now.
hello, sir.
Yeah.
Well, my question is how we to collect train data and how we collect reference.
I'm extremely sorry. Like the voice is breaking in between. Can anyone please hear the question and just?
Sir, my question is that how we collect human preference? Like we have to train AI, so we have to collect human preference. So how we collect human preference?
Yeah, as I mentioned in the presentation. Okay. One of the nicest question and good question to ask for. To answer this question, there are a lot of different forms, a lot of different ways to collect the human preferences. One is like we can just ask any of the single human, like for example, you only, to judge whether the response given by the LLM is right or wrong, right? Another way, another research which is actively being developed right now is why not call a LLM to judge whether the response is right or not, right? So like these are both possible ways where basically we can just align our systems. Also, past historic data can also help us to understand like what is the preferred response from the user's perspective and all of those things. So for let's take an example. Maybe what we can do is like ask ChatGPT, okay, and ask them like what kind of medication is needed for fever, right? And then ask some other model, like for example, Claude, to whether like that medication was right to take in that particular situation or not. That's one way. Another way is just creating a training loop among both of these models, where Claude can act as a judge to any response and ChatGPT can be a responsive model. So one can be, just, what we say generative model, which is ChatGPT, and another could be a criticizer model, which can criticize the response generated by them. And each one of them job is to ChatGPT response generative model's job is to generate the right responses, whereas Claude responses to question those responses.
or ask for the reason for those responses. That's how we can just create a loop inside that, and then we can just create a pipeline where the alignment can happen whatever the user expect. And second, as I mentioned, human annotators, human expert is another way where you can just ask from any of the humans to take the feedback, share the feedback, whether it was right or wrong, and all of those kind of things. I hope I'm able to answer the question.
Any other query?
Thank you, Dr. Saurav Yadav, for engaging and thought-provoking session. Your insights into how intelligent systems learn from human guidance and how alignment shapes trustworthy AI gave us a clear understanding of the responsibilities behind building modern language models. We truly appreciate the depth of knowledge and experience you shared with us today. Thank you for your time and for contributing to the Confluence. To mark our respect and appreciation, we now follow tradition rooted in sustainability and gratitude. I kindly invite Professor Dr. Juhi Singh Ma'am to facilitate our esteemed speaker by presenting a Tulsi sapling symbolizing knowledge, growth, and a green future. May I please request Ma'am for this token of gratitude?
Hello, Dr. Saurav. Thank you very much for your valuable session. I'm sure however, we wish to express it virtually to you. Kindly express the token of appreciation from our side. Thank you so much for being here. Thank you.
Thank you so much, ma'am, and thank you so much, Garima ma'am and Dr. Vipanera and Joy ma'am, of course, for having me here for this conference. Thank you so much.
अभी दे सकते हैं
बेटा ठीक है लोग बाहर जाने के नाम नोट करो दियार हेलो मिस्टर दियार तो बाहर जाने के नाम नोट करो
Sir, am I audible? Rajesh sir?
Oh, yes, you are audible. Am I audible to you?
Yes, sir. So can you start?
Yeah, sure. Give me 1 second. Let me share my screen.
Good morning, everyone. It is a great pleasure to welcome you to this session at Confluence. Today, we have the privilege of introducing a distinguished technology and strategic leader whose work has driven large-scale impact across data, artificial intelligence, and enterprise analytics. We are honored to introduce Mr. Dr. Rajesh Sura. Dr. Rajesh Sura is a senior technology and strategic leader with over 16 years of experience architecting enterprise scale data, AI, and analytics platforms that drive 200 billion. He has deep expertise in defining data strategies, governance framework, and platform capabilities, critical solution across data engineering, AI, and decision intelligence. He has led large-scale generative AI initiatives and products adopted by over 15,000 users, driving significant cost reduction through AI and machine learning applications and establishing enterprise-wide data governance with full regulatory compliance. He has built high-performing engineering center of excellence, improved operational efficiency, and technical depth. Sir is recognized for executive collaboration, portfolio and budget, and for translating strategic vision into stable outcomes. We are thrilled to have you with us today. I will give the privilege session to Dr. Rajesh Sudha, sharing his perspective on advanced data-driven technologies and enterprise AI solutions. So, you can start.
Cool. Hey, thanks for the warm welcome. It's definitely a genuine pleasure to be here with you all today. By the way, yeah, Rajesh Sura, Head of Data Engineering and Analytics at North America E-commerce, Amazon. Today, I'm excited to present about agentic AI and the future of applied intelligence. And when I look at this title, I want you to focus on the word confluence. All of you are graduating at the moment where two different streams are actually meeting, the stream of traditional computer science and the stream of autonomous reasoning. So when I sat where you are sitting years ago, we were in a software era. We focused on writing the perfect line of code to solve a specific problem. But as the quote on the slide says, you're not entering the software era any longer. You are entering the intelligence era. So this shift is as profound as, like moving away from a candlelight to electricity. Organizations like Google, Amazon, Meta, or even your own startup, right? They're not just looking for people who can write code anymore. They are looking for people who can architect the intelligence. So today, I'm going to share how we see this world is changing and how you can position yourself not just to survive this shift, but how do you lead this shift? Let's dive deep more on this. Let's start with to understand, where we are going. We have to respect the journey that got us here. Technology doesn't just jump, it kind of crawls, then it walks, and of course, it is now running. So look at the timeline on this slide. Back in 2010 to 2015, we were in the casual machine learning era. If you wanted to predict if a customer would buy a pair of shoes, it was very manual and of course painstaking process. So we have to hold the machine's hand through every step, and we chose the features, we cleaned the labels, and then the machine gave us a probability. So it was more of like a statistical, like calculator. And then around in 2015, deep learning came in and it just exploded. Suddenly machines started perceiving. So they could see a cat in a photo, or they could recognize your voice on Alexa device or an Echo device. But then these models were again very narrow. So what does that mean is a model that recognized faces could not suddenly decide to optimize a warehouse. So it was powerful, but it was only a specialist. So for you as graduates and researchers, the last 15 years have been about building the sense of a mission. But today, we are giving the machine a brain and hands. We are moving away from teaching machines how to see and starting to teach them how to act on behalf of a human. So then moving on to 2020, the LLM revolution happened. So we all remember when things like GPT-3 first arrived, it felt like machine finally understood us. It could write poetry, it could summarize a document, and this is a very big but, like these models are stateless, so what does that mean? They are like a brilliant person who loses their memory every time they blink. So you ask a question and the GPTs answer your question, but then they're gone. So they don't, like take a further downstream action on the answer that they have provided you. So now in 2026, we are entering the agentic AI phase. So this is the most critical leap.
Hello, sir. Am I audible?
Yes. Yes, ma'am, you are audible. Am I not audible? Hello.
Hello, sir. Am I audible?
Yes, you are audible, ma'am. Am I not audible?
Sorry for the interruption. We have just lost the power supply here. Just give us 2 minutes to sort it
Oh,
out.
sure. No problem. Yeah.
Thank you. हाँ जी सर, मुझे पता है। गुड आफ्टरनून, बताइए जी। किसको बोला था आपने? कौन से सेक्शन की बात कर रहे हैं? सेक्शन, अच्छा ओके। सर आपके भी आपको तो मार्क कर सकता है क्योंकि एक्स्ट्रा क्लास जा रहा है इसलिए, क्योंकि एक्स्ट्रा क्लास लगती है सर तो वो कैंसिल भी नहीं होती नहीं सीआर ने इन्फॉर्म किया होगा सर। आई विल चेक मैसेज कि उसने क्या लिख के भेजा है। आप मुझे एक मिनट में आपको कॉल, अरे तो मैं बात करती हूँ सर। कौन? अंकित भारद्वाज में? हाँ तो मैं उससे क्योंकि उसने गलत मैसेज मुझे क्यों किया? आई विल
लाइट चली गई थी।
Hello. Sir, am I audible?
Oh, yes, yeah, you're audible, ma'am.
Sorry for the inconvenience, sir. You can start now.
Oh, no problem at all. Yeah. So yeah, I was just talking that in 2026, we are entering the agentic AI phase. This is the most, like critical leap in the history of computing. And the reason is we have moved away from prediction to, like persistence. So what does that mean? An agentic system, it doesn't just answer your prompt. It actually pursues an objective. So it has a memory of what it has done 5 minutes ago, and it has a plan for what it will do 5 minutes from now. So if you think of traditional AI as a tool, your Gen AI is basically a consultant, and then your agentic AI is your colleague who can work along with you. So as you graduate, You need to stop thinking about AI as something that you can query, and you need to start thinking about it as something that you onboard and work along. Let's get practical. This is the best way to explain the shift to your future boss or your team members. In early 2020s, AI was just a response engine. So you asked, for instance, what is the stock price of Amazon, and it gave you a number. So it was a retrieval tool. But in 2024, it became a content engine. So you asked it, write a Python script, to track the stock price, and it did the work of a junior developer. It saved you time, and it wrote the code that is needed for you. But you still have to take that code, and you need to find a server. You need to set up an environment, and then you need to run it. So that's what you have to do with a content engine. And today, an agent, which we call it as an execution engine, so you don't have to ask for the price, and you don't have to ask it to code. You can give it a goal. You can give it a mission. I want to be alerted if the stock price drops 5% below its 30-day average. And when that happens, I want a summary of the latest earning reports sent to my email or sent to my Slack. And the agent, it decides what to do next without you. It finds the data, it writes the script, it actually schedules the job, and it monitors the results. So this is what the shift we are talking, which is from answering to your prompt to achieving what you want to do. So that is the biggest leap that we are seeing right now, and that is the evolution of AI capability. Let's dive deeper. Let's dive deeper into the distinction between generation and execution, because this is what is going to define your future career growth. So most people use generative AI for short-lived tasks. So you can generate an image and you are done, or you can summarize a meeting and you are done. So it's a one-way street. The human does all the heavy lifting for context generation. Whereas agentic AI, it can handle long-lived workflows. So it is autonomous and it can be iterative. Say, for example, at Amazon, imagine we have a sudden spike in shipping delays in a Northeast region due to a snowstorm. Your generative AI might write a polite email to the customers telling that there are delays in shipping. But what your agentic AI can do is tremendous. It can identify all the impacted shipping packages, and then it can autonomously talk to the carrier APIs to find a nearest alternate hub. And it can calculate the cost of rerouting. It can execute an rerouting order, and then notify the customer with a real-time update. So the generative AI is kind of a secretary, but the other, the agentic AI, is an actual operations manager. So as researchers, you aren't just building models that talk anymore. You're building systems that kind of govern the process. So that's the I think there's a power outage again.
Sir, am I audible?
Oh, yes, ma'am, you're audible.
So again, sorry. Now start the session.
No problem. Yeah, I was just telling that in the previous slide, generative AI, right? It can provide you context, but agentic AI is the one which can actually take that context and like automatically autonomously trigger a downstream action. So let's dive deep, like how agentic AI functions that. So to really help you visualize how this works at like an enterprise scale of Amazon, I want to walk you through a single real world example using all these different stages under the hood of agentic architecture. Imagine we have a high demand item, let's say Alexa devices, and suddenly due to a logistics delay, we are about to go out of stock in a particular region, say Northeast region. Okay. So in the previous world, a human would get an alert about this out of stock, and the humans have to spend several hours on the phone with different warehouses or on the phone with different, like carriers to figure out what's the nearest, like warehouse which can ship the inventory to that particular warehouse which is out of stock. And that takes a lot of time and effort. In the agentic world, our logistic agents can take over this autonomically. Number one, goal understanding. So what does this mean? So the agent, right? It doesn't just see low inventory error. It receives the objective. Say, for example, you have set the agent, you have given the agent a goal, maintain 99% availability for all the Alexa devices in Northeast region while keeping the shipping cost under, say, $5 per unit. So the agent understands that availability is a priority goal, but there is also a financial constraint. So it isn't just a command for the agent, it's the mission with boundaries for the agent. So goal understanding is the first stage of agentic architecture. And then comes the planning engine. So the agent now, it doesn't just start clicking the buttons, it creates a plan, checking what are all the nearby regional warehouses, which has surplus inventory. And then it compares the cost of ground shipping versus air shipping. And it also tries to see if there is a scheduled truck already heading to the Northeast region with some empty space. And then it builds a dependency graph, and all of this can happen in milliseconds. So it realizes it cannot ship to Northeast region from a Western region, because there is also a financial constraint that the shipping cost cannot go above $5 per unit. So it can automatically pivot the plan, and it will look at mid-Atlantic region, which is close by and which can deliver the products in less than $5 cost. Looks like actually I'm disconnected again.
No, sir, it's online.
I'm sorry?
It's back online.
Oh, okay, cool. So yeah, and then comes the memory and context, So this is where the agent gets really, really smart. It kind of checks its memory, and it also realizes, oh, last time when there was a snowstorm in Pennsylvania, ground shipments were delayed by 48 hours. So because of that memory, it rejects the ground shipping plan and it moves to an air shipping plan. So it always learns from the past, so it doesn't repeat the same mistake, twice. And the tool execution layer, actually both this tool execution and memory and context can be interchangeable, depending on the action that it has to take. So the tool execution plan is basically the agent reaching out. It calls the warehouse APIs to reserve the stock. It calls the logistics API to book a space on the plane, and it generates the digital paperwork. So it isn't asking permissions for every step. It is just executing the tools it has already have access to. So, and then finally, the feedback loop. Once the order is placed, the agent doesn't go to sleep mode. It monitors the flight, it sees that the plane has landed, and it also observes that the stock level in the Northeast is raising, And then it compares the final shipping cost again as the goal. So it records this as a success and refines it as an internal strategy for the next time this happens. So as university graduates and as researchers, I want you to see this. Every one of those layers, they represents a decision that used to require a human being. By architecting this stack correctly, we are now moving away from a world where we react to problems to a world where our software can proactively solve the problems even before a human knows that they exist. So this is the blueprint for systems you will be building in the next few years. Let's also talk about, like planetary scale. What does that mean? One agent on your laptop can simply be a toy, whereas 1 million agents running on AWS or Azure or Google Cloud is what we call planetary intelligence. Imagine a cybersecurity, like threat. A human team can only look at a subset of many logins. They can't go check each and every login. And even traditional machine learning model, right? It has to follow rule-based enforcement, and it can also, like look only a subset of logins based on the rules that are predefined. But if you spin up, like 10,000 security agents, and spinning up these agents can be done in seconds, they can talk to each other. If agent A finds a pattern in New York, agent B in Tokyo can immediately, like knows how to block it. So this is what we call as multiplier effect. So as you enter the workforce, don't just think about what one AI can do. Like think about what a collection of coordinated agents can do. So your job going forward, right? It is going to be the general of this digital army. So you are the ones who will build the strategy, and the agents will handle the tactical execution at scale. No human can like ever manage. I want to address, the big elephant in the room. Every time I speak at conferences, someone asks, Rajesh, like, will I have a job in 3 years? My answer is always a resounding yes. And this is the important part, your role will not look like the roles of the last decade. Look at the evolution on this slide. We are moving from execution to orchestration. In previous world, your value was in writing code. You are the manual, like laborer of digital world. But in agentic world, your value is in designing the systems that can write the code. So you're moving from being the person holding a brick to being the architect that is building, designing the skyscraper. And same thing, think about debugging. We have spent, like long nights staring at those screens and doing line by line troubleshooting. And that role is now mutating. Instead of manual debugging, you are teaching these agents how to debug. So you'll be building self-healing systems that identify their own errors, And finally, we are moving from fixed workflows to adaptive pipelines. For instance, at Amazon, we don't want a pipeline that breaks as soon as a server goes down. We want a pipeline that thinks its way around when a problem arises and self-heal itself, like be adaptive to those threats and rebuild themselves. So your degree has given you the foundation, like your engineering degree definitely gave you the foundation to understand the code. But your career will require you to be the manager of intelligence. You're not losing your job. You're being prompted to a higher level of thinking before even you start your job. And that is what the economy requires right now. Let's see, like what are some of those new jobs that are, taking over the market in real world today. We are seeing a massive demand for agentic workflow engineers. So these are not just, like programming developers. They are the people who understand how to chain, like how to create coordination or how to create orchestration across multiple AI models together with memory and tools. So they are these conductors of digital orchestra, so they kind of design interoperability. Say, for instance, they design an agent which can take an input from supply chain system and then go to a deals and promotion system and then, like create what's the best deal that needs to be, like available for customer based on the inventory and based on the pricing. And then it can also go, like create a recommendation email or create customer recommendations that are populated and communicated with the customers directly. no human in the chain. So this is what agentic workflow engineers will be building. And another one is AI auditor or reliability researcher, we call it. As we give agents more autonomy, right? So you are basically giving access to multiple systems to these agents. And the biggest risk isn't that they aren't smart enough. They can be very smart and they can be too efficient in doing the wrong thing also. So we need people who can audit the reasoning of an agent. So if an agent decides to delete a database just to save, like storage cost, it is definitely efficient, but it is very, very wrong. So we need people who can build those moral and logical compass for these systems. And these are the roles that require a deep understanding of, logic and a deep understanding of ethics and at the same time systems design. So when you prompt ChatGPT asking a question, like say, give me a script for doing so and so. It is providing you the code, but you, as a future engineer, if you want to excel in your career, you need to understand why ChatGPT gave that code in certain fashion. So that is the question that you need to be asking, and you need to understand why ChatGPT or any other GPT made a decision to provide you that kind of script. So that's what is going to be a game changer in 2026 economy. And this is perhaps the most important piece of advice that I can give you as you prepare to graduate. Your university education has been incredible in teaching you the how, like how to write an algorithm, how to structure a database, or how to train a model. But in the age of agentic AI, this how is becoming a commodity. The AI can do all this how, and it can do faster than any human. I mean, take it with a pinch of salt. There is no human who can write better code than AI, as long as AI has been given the right context. And there is no human who can write as the code as fast as AI. So this how is taking over by AI, and what the industry like say Google, Amazon, or Meta, or your own future startup needs from you is the why. Why we are building a specific agent. Why should the agent prioritize, like say customer trust over short-term profit? Why the model hallucinated in this particular, like edge case? So you need to understand that why a system is behaving in a particular fashion. So when you enter into an interview, don't just talk about the languages that like talk about the ability to define intent. Talk about your understanding of consequences for outside of that is coming out of autonomous action. So the how can definitely still get you an entry level job, but the why is the one that will build you a career. You're moving from being a human computer to being a human leader for computers. So that's the biggest change that is happening today with this whole agentic AI evolution, and you should be ready for like being part of that agentic AI evolution. I don't want to, just leave you here inspired. I also want to leave you with a to-do list. This is your 30-day playbook. First thing, I want you to simply stop chatting with AI and start building with it. Pick a repetitive task in your life. It can be very simple, like maybe organizing your research notes, or maybe summarizing your, lab results, or summarizing your exam outcomes, something like that, where an agent can go find patterns from all of your historical examination outputs, telling that, hey, here are your strengths and here are your opportunities, and try to build a multi-step agent in order to handle it. So don't just prompt AI, but connect AI to a tool. And you can do that with a lot of open source resources. I have listed some of the resources here. I'll share this presentation with the organizers. But ChatGPT again is your best friend. It can be your best mentor. All you can do is just go and ask ChatGPT itself, I want to build an agent like this with only freely available resources that are out there. And it can provide you a really good list of resources and a plan for you to, like try to build something. And second, master the audit. Every time an AI gives you an answer, challenge it. Ask it to show its work behind the answer. So look at those planning steps. If you find a flaw in its logic, then you have just performed the most valuable skill in this 2026 economy. So that is what is the key to, bring thought to progression in your career going forward. And third, but not the least, is responsibility layer. Read a lot about AI ethics and AI safety and AI guardrails. Uh, Frankly speaking, in my experience, I have spent as much time on what the AI should not do as much as I spent on what it can do. Because it is super important. You can't allow AI to do everything. So deciding what AI should do, what AI should not do, is another human role that plays like a dominance in going forward AI evolution. Yeah. So yeah, let's move on to the next slide. I know we are coming to the end of our time together, but I want to leave you with a sense of perspective. There is a lot of noise out there. There are headlines that will say AI will replace the programmer, but look at what we have discussed today. We are building systems of so much immense complexity and at the same time power that will require more human wisdom, not less. So human roles are not going to be, replaced. You are not going to be replaced by these agents. You are just being elevated by them. Think of it like a transition from a shovel to an excavator. The excavator, they did not replace the builders. It allowed the builder to move mountains. Can you really dig mountains with shovel? No, but yes, you can dig mountains with excavators. So agentic AI is like your excavator. It can take away the manual coding, the cleaning of data, the repetitive testing, all of it, and it clears it away so that you can focus on discovery, because discovery is going to be a game changer again. Earlier, machine learning models, right, both supervised and unsupervised, they provided personalized recommendations, but these personalized recommendations always have some kind of rule-based enforcement behind the scene. But today, when you are shopping, a customer, I'm just taking retail as an example because that's close to my heart. When you're shopping, the customer mind shifts very rapidly, and the speed of business also changes very rapidly. So your system has to design a deal on the fly. If you are looking at 10 products that are related to a particular activity, your system should immediately identify, is there an overstocked inventory on this particular activity products, and then create a curated deal just for you. So that is what reacting to the speed of change in business means, and that can happen only with agentic AI and no other technology. So it kind of frees the researcher or the engineer, of being, when you like basically when you walk into this room, you are actually walking into a digital workforce, which is ready to execute your vision. And I would say it's a gift. Agentic AI is a gift, and more broadly, it is a responsibility. Yeah. So here is my final challenge to the class of 2026. Before you accept your graduation, I want you to build one thing, just one, where the AI makes a real world decision without you watching it. And it doesn't have to be big. It could simply be a script that manages your emails, or an agent that summarizes your research papers. But here is the catch. You must be able to stand in front of a mirror and explain exactly why it made that decision. So if you can explain that logic, then you are an engineer. And if you can explain the intent, you are definitely a leader. So the future doesn't need more people who can act like machines. The world definitely has enough of those. And the future needs engineers who can design intelligence that can bring intent, the accountability, and the wisdom. So thank you for your time and thank you for your patience. I cannot wait to see what you guys will build. And yeah, congratulations on your forward-looking graduation.
Thank you, sir, for
Yeah.
the session. The session offered a comprehensive and insightful overview of the last 15 years of technology transformation, highlighting the evolution of artificial intelligence from conventional models to advanced generative and agentic systems. The insight that the future lies not in just chatting with AI, but in creating, designing, deploying the agentic AI encourage us to move from being passive users to responsible innovators.
Cool.
We extend our sincere gratitude to Dr. Rajesh Sura for sharing his knowledge, experience, and vision. His words have not only enriched our understanding but also inspired us to think beyond conventional boundaries. To mark our respect and appreciation, we now follow a tradition rooted in sustainability and gratitude. I kindly invite Professor Dr. Juhi Singh Nam to facilitate our esteemed speaker by presenting a Tulsi sapling symbolizing knowledge, growth, and greener future. Ma'am, please. Sir, please stop the screen sharing.
Oh yeah, sorry.
Thank you, Rajesh. That was such a wonderful and informative session. We all learned a lot from it. Since this conference is an online, able to present this physically to you. However, we wish to express our token of appreciation. We wish to offer it virtually to you. Kindly accept the small token of appreciation and a very thank you to all. Thank you to you.
No problem. Yep. Thanks.
Insights. Thank you, sir.
Thanks for the opportunity, and yeah, thanks to Dr. Garima, who has followed up closely and provided this opportunity to meet the students. Yeah, thank you. Have a good one.
Sir, some of the students might have some questions for you. Please be here.
Oh yeah, sure. Yes. And I'm also available on LinkedIn if students have any, any more questions. I also offer free mentorship, so feel free to check my LinkedIn and connect with me for free mentorship as well.
That means a lot, sir.
Hello, sir. Am I audible?
Yes, yeah.
So, sir, my question is at large scale, how your teams prevent agentic AI system from being cost unpredictable and still keeping them deployable and useful?
So yeah, number one is always working backwards from what decision AI has to make for you. You can't definitely build AI to make every decision, and we are in an evolution phase. We are not in a place where agentic AI can take over everything. So that's where in the presentation I was calling out. Understanding how agents can make a decision is playing a key role today. So we always try to first figure out what is the decision AI has to make for us and work backwards from them. So that kind of helps us to create boundaries, to create constraints. So the agents understand that, okay, hey, I can make a decision within $50 million, but I cannot make a decision beyond that. Or I can take a risk factor of, 0.8%, but not beyond that. So those are the kind of constraints and thresholds and guardrails that we have put in place. So agents can still autonomously execute, but at the same time, agents should understand when to bring the human into the loop. So if it is meeting a threshold and if it is not able to make a decision, then it automatically brings a human in the loop. Like there is an escalation path. And once the human provides some certain feedback, that is rerouted as reinforcement learning for the agent again. So next time it knows what kind of action needs to be taken when a similar situation arises. I hope I answered it.
Thank you, sir.
Any other question?
Good morning, sir. Am I audible?
Yes, yeah.
Yes, sir. So my question is, how does an agent convert natural language into structured intent?
I'm sorry?
So my question is, how does an agent convert natural language into structured intent?
Okay, so that's what we call as actually agentic framework. Basically, what happens is an NLP engine, it takes your inputs and then it converts into different vectors which are stored in an open source DB. And the actual content, right? Every LLM, right? It kind of runs on a lot of content behind the scene. So the content is also stored in form of vectors. To explain in simple language, right? Say for example, you have in-stock data. Okay, there are like billions of products, and it talks. You have database about how much inventory each of these products have. All of this data, when it is provided to an LLM, it is converted in form of vectors, which means there are a three-dimensional, two-dimensional graphs, which creates clusters. Oh, these are the keywords that needs to be grouped together and placed as a vector. So those are mathematical calculations. And now, when you prompt LLM through an NLP, the prompt is also converted into vectors, and these vectors, the OpenSearch DB, right, it will go and find the closest vector from the database, and retrieves that closest vector and provides you an output. It's a very complex and in-depth concept, which it itself can take multiple hours of presentation. If there is another opportunity, I'm more than happy to deep dive into that. Yeah.
Thank you, sir. So I couldn't understand most of it, but it was still a good experience, sir. Thank you.
Cool.
Good morning, sir.
Yes.
My question is about the multi-agent surface. So, does increasing agents increase attack vectors proportionally, or do you defend against the coordinated positioning attacks across the distributed agents? How does it work?
See, as I said again, it's all working backwards, right? So are you asking about attack on agents, like security threats, or sorry, I did not follow up your question.
About the security threat, sir. When we have
Oh yeah.
at that point,
I'm sorry.
we have distributed agents. So at that point, the security threats about that, sir.
See, security threats, right? Security threats are not directly on the agent, it's on the infrastructure. Okay. The threat on agent is mostly about bias and mostly about, prompt injections, which means a user is prompting an agent which they're not supposed to be prompting. Sometimes AI can, I'm not sure if you have heard this term called SQL injection. It's very similar terminology, and it's a very similar concept called prompt injection. So what it can do is, the threat to the agent is basically you're trying to access, or you are asking agent to execute an action which it is not supposed to execute. So those are the primary threats that I see for agents. And in distributed environment, right? It depends, are they coordinated agents, or are they independent agents which are, driving downstream actions autonomously? If they're coordinated, then there is a chance one agent, when it is performing a downstream action or passing information to a different agent, the threat, follow through across all the agents. But if they're not coordinated, then it will be a standalone threat.
All right. Thank you so much.
These are very good questions, and they have complex explanations. I'm not sure how to put these in simple words. These are really in-depth concepts that we are currently working on. Yeah.
You are very much clear, sir. Thank you so much, sir.
Yep, I have to also, drop. But if there are more questions, feel free to reach out to me on LinkedIn, and you can also find my mentoring platform on LinkedIn. It's absolutely, free for all the students. I enjoy mentorship, and I do mentorships every weekends on the Saturday and Sunday mornings. So feel free to book some time with me. Yeah. Have a good one.
Thank you, sir. That was all. Thank you.
Yep. Thanks for the opportunity.
Yeah.
Sir,
Hello, can you guys hear me?
so can we start?
Yes, we can start.
Good morning, everyone. It's a great pleasure to welcome you all to the session at Confluence. Today, we have the privilege of introducing a distinct data scientist who has driven enterprise innovation through advanced artificial intelligence and mission-critical systems. I'm honored to introduce Mr. Sandeep Singh. Mr. Sandeep Singh is an accomplished data scientist and computer science engineer with 15 years of experience in research and development, mission-critical system design, and end-to-end solution development. Architecting scalable AI and machine systems and cloud-enabled production-ready solutions that drive enterprise innovation. A cross-functional high-impact AI-driven outcomes. This is global enterprises machine learning and artificial intelligence to solve complex business challenges. He is recognized internationally for his thought leadership and technical excellence. In 2022, he was serve as an industry expert and judge for the Information Technology and Instructor Confluence Awards. His work consistently bridges advanced research with real-world enterprise deployment. Truly honored to have you with us today. I'm now having the privilege of handing the session to Mr. Sandeep Singh, who shares insights on recent developments and emerging trends in artificial intelligence and data science. So you can start with your session.
Thank you, everyone, and good morning. Can you guys hear me? If anyone can respond, can you guys see me well? Yes? No?
So we can hear you clearly.
Okay, great. Thank you guys for having me for this Confluence 2026. And today's topic, I'm going to talk about recent trends in artificial intelligence and data science. You might already have heard about a lot of research and recent trends going on in artificial intelligence. You also might have heard from great speakers in previous sessions as well. But I will really touch upon the recent trends which we are looking across our customers. So in past 24 months, we have witnessed more transformation in AI capabilities than the previous decade combined together. And today I'll share what that means for our researchers, for our students, and for our future data science. My name is Sandeep Singh, and I'm Senior Generative AI Data Scientist with Amazon Web Services, and I'm based out in California. I wish I could be there physically, but I'm dialing from California right now. I have 18 plus of his experience in research and development, and right now I'm leading generative AI team within Amazon Web Services, which builds larger scale solution for enterprise customers, solve complex business problems, and helping them to understand how can they leverage generative AI to solve their business problems and get the values, right? So in next 28 minutes or so, we will be covering 6 major trends. There are many trends going on. You will hear those trends, if not every week, like every month, new trends is coming. New trends are coming in AI field and especially in generative AI field. But we will explore 6 major trends reshaping our field, examining their implication for the research and education, and discuss what lies ahead, right? So this is going to be our agenda for today's talk. Let's talk about first trend. And as you might already have heard, or you already might have, it was discussed in previous sessions. The first trend is the transformer revolution and the foundation model. So this is a paradigm shift. 3 years back, when ChatGPT was released publicly, the AI landscape has been changed, right? But it was not that ChatGPT has released those GPT models. Industry were doing research since many years, last many years, right? So this was a paradigm shift that changed the industry. So the transformer architecture, which was published in one of the paper in 2017 by Google called "Attention is All You Need," that was the backbone for all these GPT models. So the landscape has fundamentally changed from task-specific models to large-scale foundation model. What do I mean by that? Before transformer-based architecture or before this large language model, industry or customer, they used to build models using traditional AI and machine learning for specific tasks. If I have classification task, I need to build different model. If I have image sentiment analysis task, I have to build different model. But with this transformer architecture, because these models are trained on very large amount of data, they can be used across diverse tasks without explicit training. So that is the paradigm shift, which is currently going on as a recent trend in Gen AI industry. And why I'm saying it's recently going on, because just with that transformer architecture, industry has not stopped. Daily, we are seeing that new architectures are coming. Industry are working to make those architecture more efficient, to be more available. And that's what right now it's going on. And what has happened due to this transformer revolution is there are few key developments. One is scale and capabilities. Models like GPT-4, Claude, and Llama have shown that scaling compute, data, and parameters continues to unlock new capabilities. A smaller model can do few tasks, but bigger models can do many tasks with so many capabilities, right? And nowadays with agentic AI, you were hearing about agentic AI in previous session. Due to these models, because they are getting more intelligent, more capable, more having reasoning capabilities, these models now can process multimodal data, which means not only text, they can process images, they can process diagrams, understand speech, and reason across various modalities, right? Another key development in last three and a half years is open versus closed debate. So earlier, the field was experiencing productive. Nowadays, the field is experiencing productive tension between the proprietary model and the open source model like Llama 3, Mistral. And the open source model are narrowing the gap. What does it mean is that they are democratizing access while raising important questions about safety and control, right? So the gap between the open model and the proprietary model is closing down, right? So with that, the trend what we are seeing in industry is research focus shift from architectural design to understanding emergent behavior. When I'm saying it is a shift from architectural design to understanding emergent behavior, it means that now we have ample amount of, I think, millions of models are available in the market, which are open weight models and proprietary models. But nowadays, researchers, they are talking about how can we align these model output, how can we interpret output from these models, and how can we come up with efficient time fine-tuning models so that they can be leveraged for smaller infrastructure as well. So this is the recent trend due to this transformer revolution. So due to this transformer revolution, these large language model became accessible like ChatGPT, Claude model, and many more. And now industry are focused on understanding those behavior and aligning the interpretability. So that is number one trend. Going to second top trend, which is AI agents and autonomous system. You already might be aware about these models. They are next token generation engine, right? So the transformer models, they are being trained on vast amount of data with on high memory and GPU resources, and they can understand natural language. They can produce next token based on those understanding. But just producing that next token is not going to take us anywhere. And that is where we wanted to make these large language model, or we wanted to leverage the power of this large language model to do more. Because in any industry, in any business use case, there are a lot of processes, there are a lot of workflows, there are a lot of complex decisioning which is happening behind their business processes. So how can we leverage LLM power to take those actions, to make those systems autonomous, to make those processes automated, right? So that is where AI agents and autonomous system came into picture. And this is a shift from tools to agent. So tools are nothing, just, a set of instructions which can be executed to achieve some task. But just executing tool is not the ultimate goal, but due to this reasoning capability, these models are getting more intelligent and more powerful. We can build agent which can take autonomous decision on behalf of the user, right? That's what you heard in last lecture as well. Now, due to this shift from tools to agent, now LLM can take a multi-step reasoning, and they can plan, they can also use the tools. Due to this, we have got a lot of capabilities in AI era, like research agent. System can now conduct literature reviews, formulate hypotheses, design experiment, and even write initial draft for papers. And why it is happening? Because of this reasoning capability, because of this agentic AI capabilities these models have got, right? We have seen now, due to this autonomous power, these models can generate, or these agents can generate code and develop the software. AI agents can write, debug, and refactor code across entire repository. They understand context, they follow the coding standard, and increasingly handle complex software engineering tasks. So they are becoming more and more powerful. RAG, which is retrieval augmented generation, is an architecture which allows these large language model to connect with latest or recent data so that they can leverage the power of recent data. We know that these large language models have been trained on specific data, and that data is having cutoff. So if you are going to use or you are going to ask a question to large language model after that cutoff date, it may not be able to answer. So to overcome that limit, we can now connect large language model to organizational data or your proprietary data using retrieval augmented generation architecture. So which enables these large language model to fetch relevant and semantic meaningful information from these vector database and generate right and relevant response. Now, what is the challenge? Challenge is not how to train these large language model or how to make them how to make their reasoning powerful and intelligent. The key challenge is now including in reliability and hallucination mitigation. So as we are using these agents to automate our process, as we are giving them more autonomy, the key challenge in recent trends is how we understand that these agents are taking decision that is a reliable decision. They are not hallucinating. And how do we make sure that we maintain safety in autonomous decision and developing robust evaluation framework for agent behavior? So agentic AI is one thing, but evaluating and make sure that we are building right agentic AI systems is the trend which industry is looking into as a second trend. Any question till now on these two trends? Or you can hold your question on these, and I can answer the question towards the end of session. Third is data-centric AI and synthetic AI. So data-centric AI is a recent trend which is going in current industry that researchers are putting so much effort. And the reason for that, we know all these models are very data intensive, and they are being trained on larger data set. Now, with that data and this new transformer architecture, we still see that model are still hallucinating. They generate wrong responses sometimes, right? Why it is happening? Because sometimes they create bias while they are being trained themselves, or the data itself is not clean. The data itself is not unbiased. So that is where the data-centric AI movement emphasize the systematic data improvement often yields better results than architectural innovation. We know that we can take base model, we can train that model we can fine-tune that model for specific tasks, but by making some architectural changes, we can fine-tune it. But if you have data improvement, research has shown that if you have data improvement, the data which has been used to train that model, if that data is qualitative enough rather than quantity, it will produce better result. And that is another trend which is going in industry right now, where researchers are trying to make these models more data-centric rather than architecture-centric, right? Now, why it is happening now? Now, because of this cloud infrastructure, because of this transformer architecture, training a large language model on larger data, terabytes of data is very easy. And due to that, the data is now getting short, which means that the data which is available on internet, we are almost consumed it to train these larger millions and billions of parameters model already. Now this data is, if we are not going to generate any data, if we won't be having qualitative enough data, we won't be able to enhance the performance of these AI models. So that's where synthetic data revolution is also becoming a recent trend in AI industry. And why it is needed, there are a couple of reasons. Number one, like I mentioned, is training data scarcity. These models consume increasing portion of available human generated data already has been consumed. So synthetic data generation becomes very crucial in this case. Second use case is privacy and simulation. Now, in regulated industries, for example, in medical or in financial industries where we cannot disclose personal information, and if we cannot disclose this personal information to these models cannot be trained on those data because that PIA information, personal identifier information, cannot be disclosed. So in those kind of scenario, it becomes very crucial that we generate synthetic data, which offers solution for private sensitive domains like healthcare and finance. The third one is domain adaptation. Now, for specialized field with limited label data, synthetic data generation combined with the domain expertise enable model development that was previously impossible. So if the data is not qualitative enough, it's not labeled correctly, the whatever architecture you choose to train that model is not going to take you further, right? So that's why the quality and this qualitative synthetic data is becoming recent trend in data-centric AI. And that's why this is another trend which is going on in industry, which is called data-centric AI. The fourth one is edge AI. So the edge AI is making sure that the AI models, these large language models, run on your small devices like your mobile phone, like your IoT devices, right? So that is edge computing. And before edge computing, let me talk about efficient AI. The efficient AI, as environmental concerns and computational costs are mounting, efficient AI has moved from niche interest to the central challenge. As these large language model takes a lot of energy, a lot of resources, researchers and industrialists, they are becoming more concerned about the computational cost, and they are looking towards efficient AI, meaning they're looking for more efficient methods to train these models effectively at less cost. And the key techniques to achieve that efficiency is, number one is model compression. So there are various techniques available which you can use to quantize, like quantization techniques to make this billion parameters model available for consumer hardware. For example, methods like 4-bit quantization, it maintains surprisingly same level of performance while dramatically reducing the memory requirement. So by using these quantization method, you are reducing memory footprint for these billion parameters models, which allow them to be more efficient for inference. Another technique is pruning and distillation. There are various structured and unstructured pruning methods which removes redundant parameters, while knowledge distillation transfers capability from large language model to smaller. So distillation is a technique where larger model are used to generate output, and based on those output, a smaller model is being trained so that it can generate same qualitative and with same accuracy result as good as the bigger model. By having that distillation transfer, we are making sure that the smaller model, which is distilled from the bigger model, can run on smaller devices. And lastly, efficient architectures. Various labs, various companies, various organizations, they are working and coming up with new architecture daily to make these model more efficient, right? You might have seen and heard last year, DeepSeek has released a new architecture which makes these large language model trained on smaller chips, right? So what did they do is they changed their attention mechanism. They made it more efficient, which allowed these transfer model to be trained on smaller chips. And Edge AI, the idea of Edge AI is to deploy these models on smaller devices like your mobile phone, right? And having those models or this AI capability into your smaller devices allows, number one, privacy preserving local processing. So you don't have to have these models running on cloud somewhere. They will be locally available on your device, and they will reduce latency for real-time applications. Now, because these models are compressed, these models are modeled, these model architecture are optimized, they will be running on these edge devices, which will be having less latency and so on and so forth. And having those smaller model will also be more energy efficient, which make efficient AI. So the trend what we are seeing is industry is looking towards this efficient AI along with all these transformer and other neural network techniques. Now, the fifth one, which is my second favorite, I would say, in all six trends, is physical AI. So until now, what we have seen, AI has been used in digital realm. So we have seen that companies, people, customers, they are building AI systems which are digital, which are automating some processes, which are automating some decision making. So everything is in digital realm. But what we are now witnessing is AI expansion into physical world, and that is called physical AI. It is a cross section of AI into physical world. So AI systems that interact with and manipulate the physical environment represent one of the most exciting and challenging frontier in research area. Already there are key developments which has already happened in this area. Humanoid robotics, many companies are building these humanoid robotics trained using foundation models. There are foundation models which are being trained and built for robotics domain itself, like Google DeepMind and models like RT2, which is from Google. This is model from Google RT2, which can generalize across task and environment by leveraging vision language model, right? These models are also being used. The physical AI is also being used in simulation in simulation kind of use cases, right? And applications you might have seen or you might have read that robotics have been used in manufacturing, healthcare, autonomous vehicle, agriculture, and many more industries. The research challenges physical AI represent very, very unique challenge, including the reality gap between the simulation and the actual environment. So these robots, for example, are being trained using reinforcement learning and many other advanced techniques in a simulated environment. But when actually they comes into physical environment, that is there is a huge gap, and that's why you find sometimes that your autopilot cars, they are not working very well even in US, right? So that is because there is a gap when those autopilot were tested in simulation mode versus when they actually hit the road. That is the recent research area which is going on in the company like Tesla and many advanced companies, they are working on this. Safety and reliability is very unpredictable in this area, right? So again, we are trying to build human capabilities using AI, but it is still not reliable and still have unpredictability. And this is another research area which is going in recent AI trends. And the last trend is, which is very favorite to me, is AI safety, ethics, and regulation. Although you may argue that this is a trend or not a trend, but without saying you cannot have any AI system, whether it is a digital AI or it is a physical AI, without safety, ethics, and regulation. So as AI capabilities are growing more and more, the risk and the awareness of risk is also going more and more. This trend encompasses technical safety, research, ethical framework, and emerging regulation landscape. Now, with AI safety, ethics, and regulation, there are different aspects, which is technical and as well as societal dimension. When we are talking about technical aspect, alignment research, how do we make sure that AI system pursue intended goals? How do we make sure that it represents the fundamental challenge? It achieve the output what we want to achieve, but the fundamental challenge is how we will make sure that that output is really safe and reliable. Another technical challenge is interpretability and explainability. How do we interpret the output generated by these AI systems? How can we explain those outputs? Because in mission critical systems, you cannot just randomly take those output and put into into your business, right? Into your systems. So having interpretability and explainability is very big challenge in AI world. Robustness and adversarial examples is another challenge. Now, other than that, social dimension is bias and fairness. How do we make sure the model which are being trained, the model which are being used, the AI which is being consumed is fair enough? And because of the architecture and because of the way these models are being trained, because they're probabilistic in nature, they can still hallucinate, right? How do we make sure that they are not hallucinating and the output they are generating is not biased? Many countries, they are coming up with regulatory framework, and that is where we as a researcher can contribute and advise and guide them the best practices to make AI more ethical and more safe. Now, in this AI safety and ethics, university can play a very crucial role in by training next generation and conducting independent research in AI impacts and providing those expert guidance to the policymakers so that they can create those regulatory framework for AI safety and ethics. Now, these were the 6 trends we have talked about, and we have talked about transformer architecture, we talk about AI ethics, we talk about physical AI, we talk about efficient AI, right? But what are the implications? What are the lessons we can take from this for research and education? Now, as you can see on my screen, for researcher, the current landscape offer many opportunities, as we have seen this recent trend I was discussing in the last 20-25 minutes. Now, consider focusing on domain-specific application where AI can drive scientific discovery. So, as a researcher, we can work in this area where we can drive scientific discovery, developing evaluation methodology and benchmarking for emerging capabilities, right? For graduate programs, the curriculum should evolve to include foundation in machine learning theory alongside the practical experience with modern tools. And in social science, hands-on project, and so on and so forth. And for institution, university should invest into compute resources. I know small industries and university and educational institution, they don't have that large infrastructure where they can train those larger model like these big industry can do. But they can partner for student access with these industry and create spaces for interdisciplinary AI research and ethics discussion. And they can also help, like I was discussing, develop policies for AI so that regulatory authorities can develop those ethics for AI. Now, with that, my last slide is looking ahead. What can we do in these recent trends? So several emerging areas, what we discussed, these warrant attention. The convergence of physical AI and digital AI will really accelerate value of this foundation model in spatial reasoning, right? AI for scientific discovery will promise in accelerating research across disciplines from drug discovery to material science. The democratization of AI tools will continue raising questions about access, education, and the societal adoption. So with having said that, in my closing remarks, I would say, let's start building or keep researching on these trends. I know there are many more trends, maybe hundreds more trends are going on in AI industry, but these are like few which we come across on daily basis while working with the customer, while building those applications within Amazon, with other partners. So with this 6 major trend in AI and data science, as academics, what we can do, we have unique responsibility and opportunity. Because we are training you as a future leader, we can conduct independent research and help society to navigate through this transformation. So I really encourage you to engage with any of these trends, identify the area where your expertise can make a difference, and collaborate across traditional boundaries. Now, the future of AI will be shaped by the question we ask and the problem we choose to solve and the value we embed in our work. So yeah, thank you for your attention. And I really look forward for your questions if you have any. So thank you very much.
So there are a few students who would like to ask questions.
Yeah, go ahead, please.
Sir, am I audible to?
Yes, you are audible.
So, sir, my question is like, what is the hardest challenge in making foundation model behavior reliable for real world? And how does AWS evaluate reliability in practice?
The hardest challenge is data. The hardest challenge is data. And when I'm saying data, I'm talking about quantity and the quality. So regardless of the architecture, and this is what I am seeing across many initiatives we are building within Amazon and working with various customers. So we think that we have enough or ample amount of data we have captured through digital systems, for example, payment systems, by social media and whatnot. But the data is not qualitative enough. Half of the data is not usable. We just take them as it is because it is available and try to train the model. Regardless of what architecture, how much intelligence you put into choosing that architecture, the data is the main challenge or the hardest challenge in training this model. And the second is, as I was referring to universities, educational institutions, and small organizations, they don't have infrastructure capabilities. Of course, if let's say if we have data, but we don't have that infrastructure or powerful infrastructure, that is another challenge what we are seeing that industry is facing for training while training this model. So that is, I think, answer to your first question. Now, can you repeat your second question? Is it on evaluation? How do we evaluate those models?
Yes, sir. It was like, how does AWS evaluates the reliability?
So there are various way again. We always work backwards. So reliability is very subjective. And when I'm saying very subjective, it depends on use case to use cases. If I'm working in a financial industry versus I'm working in a non-retail kind of or e-commerce kind of industry, the reliability is different in both cases. But regardless, we work backward from that use cases, what that reliability means. And based on those reliability definitions, we build guardrails. We make sure, first of all, we make sure that we are choosing right, either we are training the model for that specific use case, for that specific domain. So we are making, in that scenario, we are making sure that we are choosing the right data to train that, right? Or if we are using some off-the-shelf model or model which are already trained and available in the market, we are making sure we are having a framework where we evaluate multiple models, starting with open source model to closed source model, and make sure that we are picking the right model which is aligned to that specific use case. That is first step. Second is, once we have that, we have evaluation framework in place. I'm not saying evaluation pipeline, I'm saying evaluation framework, which start from directly user input, which is prompting, to finally responding the output to the end user. So we have end-to-end framework which keeps evaluating this whole system at every stage. Whenever prompt is going into this AI system or this large language model, if there is reasoning step happening, or let's say if this is an agentic AI system, if it is calling a tool, we are evaluating whether that agent is calling right tool or not. And then finally, once it is generating the output, we are making sure that output is not toxic. So we are building those guardrail around that system. So that is how we evaluate, by having that evaluation framework around that. So And then finally, of course, we cannot leave humans and the feedback from humans out of the loop. So having human in the loop is also another gate we put together to evaluate these systems when we are building within Amazon or outside of Amazon. Did I answer the question?
Yes, sir. You answered it, and I understand it a lot. But following up on that, since you mentioned physical AI also, right, as a major trend, so what is more challenging, connecting perceptions from sensors to model, or like defining the constraining the decisions an AI can make?
Can you repeat the question? I missed your few words here.
So, like in physical AI, what is more challenging, connecting perception from sensors to model, or
Voice is breaking. Sorry. Can you?
now is it audible?
Yeah, now it's audible. I think there was network issue in between.
So the question is, like, since you mentioned physical AI, what which of these this models?
Johi ma'am, can you type this question here? I'm having difficulty hearing. Hello? The voice is breaking.
Still,
Can you hear me?
so is it
Yeah,
audible?
sorry. I am having a problem hearing your question. If anyone can type in the chat.
Yes, sir.
In the meantime, anyone? Next question.
Oh, sir, am I audible?
Yes, now it is better.
Okay, sir. Good afternoon, sir. So my question is, how are foundation models different from traditional task-specific models?
How is
So how are foundational models
foundational? Okay. How the question is how foundational model are different than a task-specific model. Yeah. So they are different in many aspects. Number one, they are different in architecture, how they have been trained, right? The architecture, the traditional model, if you going back to those traditional AI and machine learning era where you might have heard about XGBoost, linear regression, logistic regression, those kind of model, they are trained on the objective for a specific outcome, right? And they are supervised model. And even in those unsupervised model where we were using clustering, where we were using k-nearest neighbor kind of algorithms, they were also optimized for one specific task. For example, identifying cat versus dog. So because of the architecture of those models, they were very task specific, right? Now, when it comes to foundation model, as I was telling, they are transformer architecture based, which is a backbone of this foundation model. This transformer architecture provides many advantages over traditional model architectures. Like, for example, they can look back the long sequences. They can handle more context. They can understand the relationship between those tokens, the relationship between those words, and can generate the statistic relationship between those words, and they can understand natural language. So when they can understand natural language, and these foundation model are trained on vast amount of data, along with unsupervised learning. So they don't use label data. They label data themselves only in form of like next token generation. And then they train themselves on that large amount of data. So due to the nature of the architecture, due to the nature of how data is being used in that training, these models are more capable, the transformer architecture based model are more capable understanding different tasks. Because as a human being, as our brain is able to process same data in different dimension, that's how these foundation model are very capable of understanding different nuances of the natural language, and they can perform different tasks. So that's a huge difference between the architecture and between the data, how it was used to train these models.
Yes, sir.
Did I answer?
Yes, sir. Thank you, sir.
Okay. Next question.
So it's chat. So the questions in the chat.
Is in chat? Okay, let me see. Okay, so the question is, what is more challenging in practice, connecting perception from sensor to the models, or defining and constraining the decision on AI system is allowed, like the preset boundaries for AI models? Yes, so I think this is related with physical AI, and I would say the more challenging is defining that environment and learning, interacting with that environment and learning from that environment, which is really close to the actual reality, right? So to answer your question, defining the constraint in that environment and taking a decision based on those constraint in that physical environment for these robots, for these models, is very, very challenging. And that's where reinforcement learning and constitutional AI are like basic techniques are being used in this controlled environment, but there are many research area which industries are exploring to make it happen more realistically. So I think the second piece of your question is more challenging than connecting perception from sensor to the models.
All right. So thank
Does
you.
that answer? Okay. Next question, if anyone is having.
Sir,
Yes, I can hear you.
sir, my question is from the AGI regarding the coding process. Sir, if we prove to replicators, how do you prepare the models to adapt in related learning scenarios in future?
Sorry, same voice is breaking here, I think.
So,
No, it's still breaking.
So am I audible?
Yeah, you're audible.
So due to time constraints, the students will forward those questions to you to your LinkedIn.
Yes, that will be great. Let me share my LinkedIn ID because you may find millions and deep things. So just give me 1 sec. Yeah, please follow up those questions on my LinkedIn and I'll be happy to answer your question. Just 1 sec. And here is my LinkedIn profile to everyone. All right. But thank you guys. Thank you very much for giving me this opportunity. It was awesome. I wish I could be there physically and answer all of your questions, but due to time constraint, I could not answer, but feel free to reach me out on LinkedIn. Would be happy to answer all your queries. Thank you very much.
Thank you, Mr. Sandeep Singh, for an insightful and engaging session. Discussion on recent trends in artificial intelligence and the way you the foundation models and systems of research and education give us a valuable perspective. We truly appreciate the knowledge shared with us today. Thank you for your time for contributing to Confluence. To mark our respect and appreciation for tradition, we bring sustainable gratitude. I kindly invite Professor Dr. G. Singh Ma'am to facilitate our esteemed speaker by presenting a thesis satin symbolizing knowledge, growth, and future. Professor Ma'am to present this token of gratitude.
Thank you so much.
Hello, Mr. Sandeep. Thank you very much for the informative session. As this session was in the online mode, we are unable to present the sapling physically to you. However, we would like to offer it in a virtual mode. Kindly accept our token of gratitude, token of appreciation. Thank you very much for this valuable session. Thank you.
Thank you. Thank you, ma'am. Thank you very much. And thank you each and everyone for participating and having me in this session. Really appreciate it. And looking for your queries and more opportunities like this. Thank you very much and all the best for all of your future. Have a great day.
Thank you.
Bye.
Thank you. All right. So as we come to close this session, on behalf of the organizing committee, I would like to thank the speaker. Your insights, experience, and expertise have added immense value to the conference. We truly appreciate the time, effort, and passion you have invested. Once again, thank you for your valuable contribution. We are grateful for your presence and hope to continue that from you in the future. Everyone, speaker, a round of applause. Thank you.